Ladies and gentlemen, let me declare success. We finally have got those stickers.
Did they cost
They found them.
Did it cost you $10?
No, the front.
Well, apparently it costs $10 for
Oh, okay. That is not considered $10.
You might as well get a talk.
Check, 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 check. Check one. Check, checky, check, check, check. One. Check two. Check 3 through 17. Check. 2, 2, 2, 2, 1, 2. Cool.
I got copied through so somebody, SE,
Yeah, it's always a mix, yeah.
So yes, roll around, I do have a copy.
Whoops.
I mentioned him last night on the way to
Join.
Oh.
Yes, I'm trying to get the best of it. And I looked at that, I could change. Yeah, the amount from United and I was like, you know what? So I said, I should have been there for this talk. Bill Mills himself was very disappointed. My kids. My mom and dad.
Hot sauce, anybody?
Hot sauce, hot sauce.
Yeah, of course.
Did Bill want it or not?
I don't know. I'll put it on his laptop. It's okay. He can have a drink.
Yeah, he like left it in his bag and had it.
No, it was. Cool. Finally, stickers.
It's the same standard one, right? Same standard one, like that one?
No. Color. And the rest.
It only took a year to get tired. Oh. That's how I'm impressed.
Well,
It has to be away, right?
It has to be away.
No.
Just made false positives there.
Yeah, it's like at 9 o'clock.
Yeah, because they got the one for everybody in knowing. I have to some reason wait. To read the time over here. Click on the event where it's session. That's when I look at it.
Thing is,
Who gets the speaker gifts?
I don't know.
I don't know either.
I mean, in theory, we do.
I have 3 of them.
I know, but that's because there's only 3 for the entire group. So basically, whoever wants them. So it's contact. I wouldn't mind having one. Yeah. It's basically. I mean, the whole thing is I mean, you can just take one each. So we can just decide at the end. That's it. Sort of deal. Yeah, I mean, it's the thing with these things, it's just when somebody
So
do it.
it's like time.
Well, a lot of times, some people just don't want to discuss it.
Well, exactly. I actually have room this time, so I'm okay with it. That's simple. I don't need it.
I'm not
So,
driving.
yeah.
And it is insulated with a lid on it, which would solve some small subset of problems.
It's quite nice to have something at a conference, but yeah, I'm not. Yeah, well, other than t-shirts.
Yeah, I'm getting very picky about things that I don't use.
Yeah, no, I get that. I'm starting to get that way myself. The last couple of conferences I've been at, I think I've got very much swag, partly because there's not a lot of swag, and partly because like I just want to hear that crap.
I think a lot of people are realizing that handing out swag and endless pieces of paper is going straight to the trash. And you've got to make your impressions in different ways.
Yep, that's it. Get a few people in, it's good. I had to find a bathroom before we started. Well, other than chat, I guess we're ready.
It's like magnolia.
Yes.
It's like something else.
You change. Otherwise, the problems like everybody can handle some like White House, all the stuff, and there was one that looked very so they looked at something black and cheap. I find it funny that all this stuff. Or if it's a tree, if it's a flower, every place at some point. Just like every organization. Kitchen workers.
Capture all what make people talk.
I was just saying that every organization is talking about like the dog or whatever, they always take some process, like, they all got a tree and a bird and every organization. I don't know. I think we should tell Richard, we sat down and told him to make a sign. We should probably tell him to do it.
It's gonna be a Yahtzee.
It's a service. Here's the new on.
These service now, or just like we get sued.
It's kind of a little people.
Exactly.
Those little floppy, kind of things that look like that, like little pom-poms on the end. Yep, that's what
What kind of hot screens build? We need to hack like the other project for build system.
So, one That's good. That's clever. We're supposed to inspire confidence, guys. Come on. That's it. You're playing on stereotypes. This is I just want to point out we're trying to inspire confidence. Exactly. Been there, done that. It sucks.
We don't need another build system.
Build straight.
Build streets. Exactly. I love the XKCD. Yeah. Yeah. Whether it's NTP or whatever.
Every problem has built system. Of course.
Yeah.
Ah, finally, I'll get the mule sauce on.
It's got your card, man.
I ended up with one at Foster last year, stuck in the bag, forgot about it.
Oh no.
Until I hit security at Heathrow.
Oh no.
And they're rejecting my bag. And I'm like, I don't know what's going on.
Oh no.
And then they found, I mean, it's an old bag, so that's it.
Sure.
I never even thought to look there. Sure enough, they find it. I'm like, oh, that.
Damn it.
Enjoy your mule sauce.
I would just be stunned. I want to know why. I would be out there.
Okay, you know about the help desk, right?
Are we good?
No.
Not good.
No, they're working on it.
Yeah, that's what I last time I looked. That's what it said. I said sorry.
So I was doing, I know something that is smart.
So we'll probably kind of have to watch,
One of us, one of us probably have to, once people start talking, that's the reason one of us is watching the chat. One of us is running the
Yeah.
because you want to make sure that if the speaker doesn't see it or whatever. In theory, it can be up from one of them. And one of them would have to
You are currently the only person in this conference.
He's one of the one I think people still have.
Yep, we have 3 uploader sites.
Well, they just restarted everything, so.
Going to the bar.
Oh boy.
Going to the bar and getting a drink.
Yeah.
All right, well, at least we have the right chat. That's cool.
I'm just gonna pay
All right. Hopefully I can.
So we. Nobody told me. And then I went back.
The main
One team that's from like. You just let me at you. I send a message.
All right.
It was last night, that's why.
Okay, good. I'll one sec here. Okay.
I didn't know you could do this, but that's the only reason that it's an hour. And I took part of the reason. Yeah, they managed 2 hours, 40
Okay, cool. I think we're good. You got to reload. I think you've got to reload. Reload. Rejoin though.
That one is new. I just made it. Do you have the money or the one that you
For the first time, the one next year, 2024. Yeah, so the doctor, that's
Yeah, well, the number is improved of knowledge. That's
Yeah.
Yeah, it's a party. And this is knowledge that what we want is yeah, and most of our logos are done some way or the other. It's occasionally a couple. And then members of the one thing that we're most known for, and the only big program at the moment. Hopefully there will be something else soon. But
Still shielding.
I did the sticker thing for quite some
What's up?
I'm gonna grab my power supply from my laptop.
Okay.
Do you have the or somewhere to be shared eventually?
I would not want anybody else using it at the current point, I guess. attempted eventually giving.
Yeah, is what I'm already, but the interesting one would be that spin up, push, run, and tear down.
We're fetching anything if it's not there, and making sure it's sterile, and then redoing it. And then redoing the setup.
Yes.
But you're using one specific runner or
Totally.
Like, I have my own one of these.
Well, hopefully.
Do you want me to go ahead and start that?
That's great. I was trying to find the mic so we can start. I told Joshua that we'll introduce things, introduce everything, thank the sponsors, and then pass it to him. So, we have to that mic?
Yeah, I'm pretty sure. Does this make me sound loud? I think this makes me sound loud.
I think so.
It does.
Anybody hear us?
We
Yes.
have microphones.
Okay, cool.
Tap on it a little. There we go.
I think so, yeah. Remember, you gotta introduce everything, let everyone know that they have to talk on the mic.
Yeah. Talk to the microphone, turn your camera on if you're remote and you're trying to interrupt.
So we do.
Yep.
And you know, questions and
Yep.
whatever is
Yep.
urgent.
Okay, let's go ahead and get started. Everyone, be quiet. So welcome to the first ever Build Systems micro conference. Bian and I have been tossing this idea around for, I don't know, forever. And we finally submitted one and it was approved. And anything that does not go well is basically my fault.
No,
Well,
my fault.
okay, well, we'll blame each other. So please go easy on us. Be nice to our speakers. Hopefully we have some interesting problems to discuss today. Remember that the answer is not build system A is better than B because it does it this way. It's we do things this way and we think it has that benefits. I'm now paraphrasing Steve Rostedt from an earlier meeting where he told me I couldn't say what I normally say. Please interact with the speakers. There's plenty of time for question, answer, interaction, you know, trying to really understand the problems that hopefully we all face as people building distributions for various Linux systems. Due to the background of the organizers, we may say one word more than another, and we're sorry about that. If you're remote and you're trying to speak, turn your camera on because I think it will give us a little bit better awareness that you're trying to speak. And if you're speaking and you're not muted and your camera's on, we can catch it faster. And questions, answers. Speak to the catch box.
If you want to talk, just put your hand up. We'll throw the box to you. We apologize ahead of time if anyone gets hit in the wrong place. But yeah, please try to catch it instead of hitting your neighbor.
We did practice. Well,
yeah, but you don't count.
Yeah, you were filming it. And with that, I would like to introduce Joshua Locke, and he is going to talk to us about making sure we're building what we think we are and how we know we have the right thing, which is a very important topic. Joshua, can you take presenter now?
It's an excellent question.
And you should be able to use the plus sign to find your slides. Plus sign lower left.
Lovely. There we go. Got them. Brilliant. Thanks for that. Okay, so yeah, my name is Joshua. I'm dialing in from the UK. Good morning to you all. I work in Verizon's Open Source Program Office. I want to talk a bit about securing build platforms. What's a build platform versus a build system? A build platform is basically the software, hardware, and people that you have to trust to have confidence that a built artifact is what you expect it to be. It was produced how you expected it to be produced. Why might we care about that? Well, open source has a lot of very kind of hopeful notions. So Linus's law was kind of invalidated, but I think the concept speaks to a wider expectation, which is that if I look at the source code and I give myself some confidence in the source code by doing that analysis, then the kind of package or the project can be trusted. But people rarely consume source code directly. Typically, they're consuming some kind of artifact, a package, and that is a composition of the source code, some kind of recipe that tells you how to build the source code, and the builder that performs all of the operations. But we still have this expectation that the artifact was produced from the expected source, using the expected recipe, and on a somewhat trustworthy builder. But as we have seen time and time again over recent years, and at an increasingly alarming pace, this is often not the case. So I've got a few screenshots of different attacks on build platforms. So this one was someone made a malicious commit to a GitHub repository and was able to compromise a component and benefit from some cryptocurrency stuffing. A little bit closer to home, I think, for many of us, the core source code management repository for PHP was compromised, and commits were introduced to that project, which seemed to be authored by very trusted and senior members of that community, but actually were not at all authored by those people. Quite a long time ago now, the webmin project was compromised for a very long time because the build system was building from a modified source tarball. So they were the source code all checked out, the tarballs that people were downloading from the internet all seemed to check out, but the actual built product was somewhat seriously compromised. There's also been attacks where people have become trusted maintainers in communities, taken over like some of the responsibilities for packages, and then added malicious dependencies, which have done things like scraping cryptocurrency wallets and profiting from that. Very famously, the SolarWinds software was targeted by a nation-state attacker, and there was a pretty sophisticated compromise of their build process, which resulted in a piece of source code being replaced at build time to build a compromised version of the package. And the CodeCov tool was compromised such that many tools and users were pulling a script from their website to utilize the tool and not verifying that script against the published checksum, and an attacker was able to upload a modified version of the script and get away with doing dastardly things on CI systems for quite a long time. So this is a very brief tour to paint a kind of somewhat intimidating picture. And now let's think, what can we do about it? And one of the things that I think is important to bear in mind is that Linux distributions have been, and Linux distribution build platforms have a much stronger starting point than most CI/CD pipelines and build platforms. The packager is typically an additional role which adds additional checks to the whole process. Very often, or usually, Linux build systems have a recipe which goes through some kind of peer review process. Distributions tend to cache or mirror the inputs to the build, not just pull them directly from the upstream each time they want to perform build. And fortunately, we've largely moved away from uploading locally built binary artifacts to our distribution archives. But that doesn't mean we should be complacent. So let's take a look around and see what other people are doing to solve this kind of problem. Google has very sophisticated system called binary authorization for Borg, which, as I understand it, is part of a larger effort to increase the sophistication of, or this was a historical effort, but to increase the sophistication of Google's systems to defend from insider threats. And one of the key tenets of binary authorization for Borg is that changes cannot be effected without multi-party approval and going through some kind of review process. So single malicious actor can't compromise the system significantly. In adjacent spaces, we're seeing a lot of kind of different package managers, open source package managers, taking steps to harden their kind of pipeline. So here you can see that the Homebrew system, which is kind of a user space package manager for Mac OS and Linux systems, they're trying to add an assertion that somewhat proves that the binary artifacts are produced from the expected builder. And the NPM project has similarly made changes to link a package back to its source repository in a verifiable way. And Linux distributions have also reacted to the recent changes in focus of attackers to what's often called the software supply chain. And so SUSE published a paper on their website describing how their build platform, I can't remember what the acronym expands to nowadays, but OBS, their build platform, how that implements various security features and what additional features they were looking to implement. And the Flatcar container Linux has also been taking steps to prevent tampering and improve integrity of their infrastructure. And people who either read my submission ahead of time or were paying a lot of attention will have seen this acronym pop up in many of the previous slides. SALSA is the Supply Chain Levels for Software Artifacts project. And that is effectively, Google took their binary authentication for Borg notions, tried to generalize them to be applicable outside of the Googleplex, and published it as an open source project. And so the key components of kind of a SALSA architecture that an ecosystem kind of holistically adopts this set of concepts so that they have a trusted platform which guarantees some isolation strength and what's called provenance generation, which is effectively authenticated metadata describing the inputs to the system. And then they have a way to, this ecosystem has to have a way to define what the expectations on the ecosystem are. So a way to convey who is the, what are the trusted builders, what is the kind of canonical source repository for a given package. And exactly how those expectations are defined can vary a lot by ecosystem. It might be trust on first use. So if I fetch a package and it's built from source code in a given GitHub repository, and then the next time I fetch it, it's built from source code in a SourceForge repository, I might not install that package and do some analysis before I trust it again. But there are other mechanisms for defining these expectations. For example, the Go ecosystem doesn't strictly adopt SALSA, but they do have this. Their source code URIs are kind of embedded in their package namespace. So if the source code moves between package versions, there's a mechanism to detect that and trigger some kind of analysis. And then the final piece of adoption would be some verification that the expectations met and that the trusted platforms were used. So you might do this at repository admission time if you're uploading to a distribution archive, or you might do it at install time within your package manager. There are doubtless other options available. And then to try and make this set of abstract concepts a little more concrete, I'm naming a system. As Philip said, it's just the one that I happen to be much more familiar with. I have worked on the Octo project for a very long time and touched most of the systems labeled in this diagram. So if we take the diagram that was earlier, that I used in the earlier slide that where it defines what a build platform is, this kind of maps that build platform to the different pieces of how the Yocto project's artifacts are built on their public infrastructure. And then we can think about what would it take to adapt or adopt SLSA within that ecosystem. Well, SLSA is broken down into build levels, and each level provides increasing assurances that meet the security objectives of the project. So SLSA build level 1 is that we generate this provenance, this description of the inputs in the build process, and we could do that with a BuildBot plugin on the Yocto project system pretty easily. We would then get to SLSA build level 2 by signing that generated provenance to bind it to the trusted builders, and that would already help us detect attacks like the CodeCov and Webmin attack. SLSA build level 3 starts to add stronger requirements, which would require a little bit more significant effort, both from a strict engineering kind of hands-on keyboard implementation perspective, but also maybe rethinking some of the ways that the Yocto project build systems are kind of hosted and deployed. So I've left that as an exercise for future. Haven't gone into great detail about how we might achieve that here. But that is ultimately my prepared material. So we've defined a build platform. We've talked about some of the reasons why we might want to secure a build platform. And I've made a proposal for how we might use the SLSA project to secure a Linux distribution build platform. And I spoke for quite a long time. Apologies for that.
Okay, does anyone have any thoughts on this? I'm sort of curious. You didn't define the SLSA build levels, what they're looking for at each level. What might they be looking for? What would you have to satisfy to get to level 3?
That's an excellent question. So at level 3, it is looking for a high level kind of a hardened build platform. So it's looking for strict isolation between the tenants of the platform and between the platform level code that might generate the provenance and the processes running on that platform. And that's why it can be a little more invasive than some of the earlier levels.
Yeah, okay.
Is any of this shareable between build systems? Can provenance be used by another, potentially by a different build system? In other words, is there cooperation possible?
Yeah, absolutely, it is. Yeah, there's nothing in the verification logic that binds it to a specific build system. There is SLSA is a relatively new project, and adoption is happening as the slides indicate. But right now, the kind of verification piece implicitly has this notion of, you have these expectations, you know where you think, or something knows where the source code should be coming from, and what builders it should be built on. And this is effectively a policy, and we don't have a well-defined architecture or expectation of how you might define that policy and use it across systems. But that is absolutely a goal, is that you can generate SLSA provenance, which is a well-defined format, in multiple places, and kind of consume it in disparate systems and evaluate it against a set of expectations and improve your confidence. And so there, it's defining the expectations that is the missing piece there, I think. And to a certain extent, we need more systems generating the data that we can try and figure out how to plug together. But there's nothing intrinsic that binds the provenance to the systems or ecosystems that generate it.
So I was wondering, does reproducibility and having multiple agents or separate entities building it and getting the same result. Does that factor in here somehow?
Potentially, yes. It's a good question. We haven't broken this down in a way that we're all kind of comfortable with, and that's why it's not published on our website. But a few people have speculated about how you might use reproducible builds to form this notion of a trusted builder without explicitly having to say, this one system I trust and think it will never be compromised. There's certainly a synthesis, and the earlier versions of SALSA did include the recommendation to use reproducible builds at higher build levels. But we had a level 4 before we hit 1.0, and we pruned it for that initial release because we didn't have a set of security objectives that we were very confident in that could map to different ecosystems. So yes, that's a very wishy-washy answer, I realize. The concept definitely fits. We're just not entirely certain how. One of the challenges with a project like SALSA is we're trying to map it to build systems across lots of different domains.
Yeah, certainly reproducibility is useful when it's achievable. So there's certainly, there's lots of prior art there. Before SALSA was the thing, before reproducible builds, before supply chain security was like a hot term, there were people paying attention to this. So there's prior art in, for example, the Tor project, where building a browser. A browser is a fairly complex assembled piece of software across a whole bunch of different things. They were able to do reproducible builds of that. There's certainly the Open Embedded project has been involved in, and the reproducible build summits and everything since the beginning. Debian has been doing work there. That's all nice. That's all good. That's all valuable. Not just saying where you're you want to be able to answer the question, okay, given this binary artifact, where did my source, what went into building it? What is the transitive dependency closure from a trust perspective and an integrity perspective on that artifact? And so one approach to solving that I think works extremely well and is can generate these results not just in a oh yes, we documented what our inputs are, but in a verifiable, provable way, is what Nix does. And so in Nix, for those who aren't familiar with it, you have every build of a package cryptographically identifies all of the inputs that go into building that. And so after you have a build artifact, you can look at what is the tree of all of the things that went into building this particular package, this particular time. And so if you have stuff that's not reproducible, this is really useful, and you can go and see not just, oh, some diffoscope output of where does my reproducibility in this binary artifact come from, but where in my chain of dependencies might that be coming from? And so that's really useful. And then that is a whole ecosystem of stuff that's being built. And so you can check reproducibility across a whole ecosystem. And one of the additional tools that they've built within that ecosystem is a thing called Trustix, which the idea behind that is you would have, as part of the infrastructure of the ecosystem that provides the binary cache for here's your pre-built packages, you would also have a way for people to do distributed builds of all of the software that you have in that ecosystem, and to be able to aggregate signatures of claims of, yes, I built this thing, and then when you go to trust an artifact, you can say, oh, yes, I will only trust this if N of M parties all agree. And that's something that was actually built. So there was efforts to do that in Debian a while ago with like the Debian rebuilders. I don't know if that actually ever, I didn't follow it closely enough to know whether that ended up being usefully deployed in practice. I'm not aware of that happening. I'm not saying it hasn't, but that's, yeah. So there's a lot of interesting prior art there that's useful. Certainly useful if you can have reproducible builds, also useful if you can't, and also helps you get there.
That's a really good kind of summary of the verifiably reproducible builds concept. And I think one of the kind of trade-offs that people have to make is whether they want to trust and harden a single platform, or whether they want to try and build some kind of consensus around whether a component is verifiable across different builders, or both for the the super paranoid or the very security conscious.
So I assume that that when you're talking about isolated builds, you're talking about using something like virtual machines or containers, where you've got all of the toolchain elements like signed and verified. Is that correct? Is that how that's done, or is there some other secret sauce there?
Yeah, the expectation is that it's probably containers or ideally VMs. Celsa tries not to be too prescriptive. One of the things we're trying to figure out is that when platforms make these reasonable decisions, like whether to use containers or VMs or some potentially stronger isolation mechanism, how do they articulate that so that the people consuming those packages can make a trust decision? Like it's okay. It's all well and good for a platform to say we build Celsa build level 3 packages and you can trust us, but if you don't have any insight into how that builder works and how they're making those assertions, on what basis, it's not super reassuring. And so effectively the platform has to make certain decisions about those kind of things and then be able to articulate them to the end users.
I would assume that in some kind of utopian future, we might have like a validated Docker container, with either Debian or Ubuntu in it, that was not necessarily those, but hypothetically, that had and all the tool chains validated and all the other tools validated on the system, so there were no leaks. And then if people built with that, you could trust it, but you'd have to sign everything. So.
Go ahead and get the guy behind you.
Thanks. Seems like this is really good. We're concerning ourselves with the what. I'm curious how deep this goes into the is, and by that I mean, there's well-known cases of certain universities trying to test the vulnerability of the Linux kernel, those kinds of things. And I was really impressed with the reaction. Greg just walked out. I was going to bait him into responding here. I was really impressed with the response by the Linux kernel team to that. I think it was appropriate and well measured. We don't know the degree to which other projects do that. So I hate to call it a credit rating, but is there some sort of credit rating we could apply to like a level 3 certified build, such that only things above this waterline, or maybe they're below the waterline, but we've done work to get them above that waterline or in it, so such that I just know if it's level 3, the work has been done to ensure that the ingredients are also relatively pure.
I think that's an excellent question. The Celsa project is an open source project that's part of the Open Source Security Foundation, which is one of the Linux Foundation's child foundations, I suppose. And within that organization, there have been discussions like, can we do some kind of certification of Celsa, so that if you go and choose some builder and they have been and they are a certified Celsa builder, then you can have a high level of confidence in the produced artifacts. I just don't personally feel like Celsa is quite ready for that yet, and so I haven't been too engaged in those conversations, but I think it's an aspiration.
One other thing that I was wondering about is air-gapped build systems. Is there a way of supporting that? It sounds like in a lot of situations like this, network access is required in order to get a lot of these things. I've worked with a number of people where essentially all of their builds, all the inputs are in theory vetted, put into private repositories, and go from there. So how does that work in a situation where the build systems are completely isolated?
Great question as well. I haven't done a kind of detailed analysis of this, but there is certainly support within the Salsa ecosystem for being able to verify claims where you don't have all of the evidence. So we have this additional metadata format, which is called a verification summary attestation, VSA. And basically that is where you can say, I trust the previous evaluations by this system that this artifact meets Salsa build level 2, for example. And so you could imagine air gapping a bunch of binaries and doing that verification at air gap time, and then producing this attestation summary to say.
So sort of like a peer-to-peer trust environment, like GPG or something, or
less of a peer-to-peer thing and more of a kind of at the time the air gapped environment was caching all of the binaries. It could do the verification against the upstream sources and attest that at this time the expectations were met.
I'm sure that'd probably help. Thanks.
So to respond to that, one of the things that we've done in the Cubes OS project a long time ago was exactly that: make sure that you can get all of your inputs at one stage, verify them all, and then build everything in an offline environment. And that's the build of the operating system is then done in a virtual machine that has no network interface. And that's been validated. I mean, that's my system runs at it. It works. And then to your question about what is, I happen to know that at least as of the last time that I checked, that Cubes is also what Konstantin from the Linux Foundation is using to administer all the Linux Foundation infrastructure. So this is a thing that is being done. And it's not just Cubes, also, so Nix benefits from this as well in a generalizable way that doesn't require work being done up front for your particular project. The way that they do that is when you have a derivation, which is their name for a build script, kind of, and you're doing this in the normal build sandbox, there's two modes that you can be in. One is a somewhat hermetic environment where you don't have access to the outside world. And so the theory is your output should be a pure function of all of your inputs. And then sometimes, of course, you do need access to the outside world to, for example, fetch things. When you do that, the default way that all of these packages are written is such that your output should be what's called a fixed output derivation, where you should know a priori the hash of the thing that you're trying to download. And so, for example, if you're fetching sources, you would have, okay, yes, we are fetching this using curl, git, whatever, and a network, and it's some highly variable thing, but we can verify that the output is fixed. And so that means that transitively, everything in your system either is a pure function which should be reproducible, or has side effects and interacts with the global world, but the extent to which that can permeate through the rest of your infrastructure is bounded at that point by requiring that the output be fixed and known by its hash. So that's a solution that I've found in practice generalizes quite well. And I've used that for things that are not operating systems, like even just, building random firmware for embedded stuff that doesn't even like have a kernel. Like it's a pretty, and as applications too, like this is a pretty good approach. Well, no, sorry. I have found this approach to be beneficial. Yeah, there we go.
Just want to say that what I'm talking about goes a little bit further than that. When I said air gapped, I mean literally no network connection between the build systems and the rest of the world. So there's only so much that you can prove in that situation. The code essentially has to be hand carried from one system to the other in order for things to work appropriately. It's a very difficult problem, and one where quite often there are people that, in theory, vet the code crossing that gap, which then makes it very hard if they don't vet all of the appropriate code that was built as a part of the reproducible build in the first place. But I appreciate your answers, and I'm sure that all this stuff is going to be very helpful for the people involved.
There's also an interesting side effect for this kind of hermeticity. We're using this for the Android kernel builds to like have all the inputs like on disk and no network access during the actual build. And the benefit basically is because we are building a system that is used by many partners. It's run on arbitrary infrastructure, but for the binary that comes out of there, we guarantee ABI stability, no matter where it's built and when it's built and by whom. And so that the side effect of these hermetic builds are obviously that you have less of issues, with that. So like the amount of bug reports you get where the build is actually at fault and things that you cannot reproduce in your lab anymore are like going towards zero if you have hermeticity as a standard. And even if you're just saying hermeticity and reproducibility is a different beast to that. But if you're getting close to that and know the unknowns, or like the things that are preventing you from that, that's really beneficial as a side effect besides the security aspect of it.
Just pointing out that that's on the chat.
Oh, thanks.
I think Masahiro is pointing out that there's documentation in the kernel build, K-build documentation for reproducibility.
Yes. And there's of course reproducibility of individual built projects, and then of course at the system level as well. And of course, depending what area you work on, it's going to be one or more of those kinds of things. So, but all those are very important. Are there any? We're just coming down to the last 5 minutes or so of the space. Are there any last questions that people want to? Things people want to add to that? Do you have another one? Sure. No, sure.
It's probably worth giving a pointer and shout out to the Bootstrappable Builds project too. So your point earlier about like, or your point about it'd be great if we had this Debian container, Ubuntu container, virtual machine, or whatever. That's a lot of stuff. That's a lot of software in there that you have to trust. Having a minimal environment for like having the size of your TCB for building, the size of the set of things that you need to trust, the transitive dependency closure from an integrity perspective, be proportional to the size of the set of dependencies that you have for what you're actually trying to build is nice. Again, Nix and Geeks do that really well. The other thing is there's the question of how you arrive at that build artifact in the first place, and there's all the reflections on trusting trust style issues. So the bootstrappable builds folks have done a really excellent Herculean effort to go from to bootstrap such an environment, right? Because how do you trust that initial binary? How do you trust that initial image? How do you know that that's not already backdoored? That is when you don't know whether you can trust your software supply chain, that is an important problem. And the bootstrappable builds folks have done some really great work that is relevant and worth taking a look at to be able to get to that initial point. And it's also well integrated in Nix and Geeks.
I just dropped a couple of links in the chat to a Geeks blog post describing their full source bootstrap using the Bootstrappable Builds project, and then the Bootstrappable Builds project's website as well. They're great references.
Oh, that's awesome. Thank you very much. Any last thoughts? If not, we'd like to thank our speaker. Thank you very much, Joshua. We really appreciate your time and slides, and thank you very much for bringing all this stuff, and of course everybody's input on the topic as well. So thank you very much.
Yeah, thanks everyone for the discussion.
The next talk is going to be coming just a second, and it's John Moon. So we'll just get him all set up and go from there. Let's see. Let's just get. This is the API. Yeah, just want to make sure I chose the right slides here for you. Cool. Thank you so much. And I think you need, I guess you can see the mic there. So, yeah, okay. And same deal, if people are asking questions, we'll just make sure they get the mic for you.
Okay, sounds good.
Yeah. But just wait a minute and we'll get started.
All right.
That's really cool.
Sorry, not. You know, good.
Okay, just about time to start the next talk. Next, we're going to have a talk by John Moon talking about improving UAPI compatibility reviewed with automated tooling.
Yeah.
And again, like I said before, just so everybody else on the stream can hear and whatnot, if you have a question, just put your hand up. We'll throw the mic to you, and of course, we can go from there. So,
yeah. And please do interrupt with questions during the talk. That'd be lovely. So, yeah. So, hi everyone. I'm John Moon. I'm a software engineer with Qualcomm. I'm going to talk to you about UAPI compatibility and how we can improve review. Yeah. So I'm kind of going to go over the art of the possible, what's being done today, and what we can do in the future. All right. So first, high-level overview. What is a UAPI? For the purposes of this talk, when we say UAPI, we mean any interface between kernel space and user space. So that's going to be your system calls, your UAPI headers that include bioctal structures, sysfs, procfs, even module parameters. There are other things, maybe debugfs, but we don't really consider that stable since it's debug. Basically, anything in the kernel that could change and break a user space program is going to be a UAPI. And over on the right-hand side, we have a struct that's used for an ioctal somewhere. And you can see in the bottom this comment that says, hey, we needed to change this to V2, so this one is deprecated. So likely the kernel developer wanted to change the structure in some fundamental way, but they couldn't change the structure because a user space program might be using it. So they had to create a new structure, V2, and move on from there. Linux famously does not break user space. I've heard Greg refer to this as the Cambridge promise. So yeah, if sometimes in Linux development, you'll go through and refactor things, or sometimes remove really old stuff that nobody's using. But if it does turn out later after you remove it that people complain, then that change needs to be reverted, and you have to support it. We can't break UAPI. So today, to maintain UAPI compatibility, as far as I can tell, this is what we're doing. We have code review. The maintainers get a patch. They look it over. Okay, is this going to be breaking any user space? And then once it gets merged, it goes out to the whole testing universe for Linux. And if any user space programs break there, then they can report it back upstream. And if it was indeed a breaking change, it'll get reverted. So what we're trying to bring to the table is some automated tooling to help with this process. So what do we actually have? So strange sound. So today we're trying to upstream this shell script called checkuapi.sh. Here's the lore link. Please go check it out and comment and participate in a discussion. Welcome to criticism. This is the command line interface. It's fairly straightforward. You provide a base tree and some Git reference in the past. And then the basic business logic is to run make headers install on point A and point B and populate two parallel header trees. And then we diff all of the headers in those trees. And it's not just a textual diff. We use ABI diff, which is a libabigail command line tool.
So we, for example, we have this structure over here, struct foo. We added this new member z in between x and y. And ABI diff is going to report, hey, your offset of y changed and the size of the structure changed. So that's an incompatible change. In a lot of cases, ABI diff can be kind of overzealous when you're examining kernel code. So like a very common pattern you see in kernel code is having an enum that has an underscore max variable at the end. And by default, if you push this change into ABI diff, it'll complain about the color max variant changing from 2 to 3. But with suppressions, you can pass in certain kind of patterns, certain kinds of different conditions for things that ABI diff can suppress. So in this case, we added this regular expression match where, okay, if you have a changed enumerator variant that ends in underscore max, we don't really care about that. That's fine. And shout out to Doji on the libabigail team. In the earlier revisions of this patch, we got a bunch of feedback that there were too many false positives. So we worked with libabigail upstream and tried to add additional suppressions to cover these corner cases. So now I'm going to go through a few examples to just kind of help get the ergonomics of how this script works. So here's a simple example. We just added a pound define foo to some header file. That's not going to be a breaking change. So you run the script and it goes through all 912 UAPI header files that get installed by make headers install. And I guess we'll get to it later why we have to check every single one. But one other thing to note, if you run the script with no arguments, it will, well, if you have a dirty git tree, it will check your head against the dirty git tree. And if it's a clean tree, it'll check head against head -1. So here's another example. We have a structure, and we're changing the last member from a signed 32-bit int to an unsigned 32-bit int. You run the script, it's going to complain about this. So the size of the structure hasn't changed, so your ioctl code's not going to change, but it is potentially possible maybe you have a user space program that was passing in a negative number or something. There could be some incompatibility potentially. So the script does report it. But if you pass the -i parameter, then it's going to say, it's going to ignore ambiguous changes. So it is possible that a kernel space driver was processing the, it's possible that this was a compatible change. So if it's impossible for user space to pass in a negative number for one reason or another, then we can ignore this. Here's another example. We move destination register below source register, so we're just moving a struct member. In this case, what do you guys think? Is this going to be a breaking change? Yeah. So even if you pass the -i flag here, that's going to be flagged as a breaking change. Any user space program using either of those is gonna break. So here we're making a change to an ARM64 header. We're adding a new variable to the end of the structure, and if I run the script, we see, hey, there were no changes to UAPI headers. Now the reason I have this is I'm running on an x86 machine, so when I run make headers install, the parallel trees don't include the ARM64 headers. But if you pass in a cross compiler and set the arch variable, then it will install make headers install correctly and go check those headers. One other thing to note here is 884 headers were checked now instead of the 912. They're just fewer headers for ARM64. So now, in general, you can also pass -i here, and it doesn't report it as a breaking change. So adding a new variable to the end of the structure does change the size of the struct, but it is technically possible to handle this kind of expansion in kernel space. You can map your ioctls correctly to go to the same command. And if you use copy struct from user and IOC size, then the kernel will automatically 0 extend your structure or truncate your structure to deal with the disagreement in the size. So if your kernel driver is able to see that new variable and know if it's set to 0, that means user space didn't have this notion of new variable, then it can be okay. So in this case, we treat it as an ambiguously breaking change. I'm open to feedback about that. But.
It depends on user space, right? So in this case, SIG context can likely get embedded in U context, and then it gets embedded in interpreters for signal handling. So it's not safe to make these changes. So, but it's context dependent in user space whether or not these things are safe or not. So if you, I guess you can't pass -I every time, right? So you have to know what's going on in this case.
Okay.
So, and usually the biggest case is like, I think we broke this on S390 at one point in user space, and it breaks a Perl interpreter and like a Python interpreter because they have a struct inside of a struct. And so it's it matters how big the thing is at this point, and you can't change them. There's a lot of user space structs that you can't change.
Yeah.
The struct by struct will be called out as non-ambiguous.
No, but it's a struct in the kernel space, but in user space, you stick it inside of another struct.
Oh.
Can't control that. Okay. Yeah, that's an interesting point.
Yeah, I'd say like the interesting point to consider is here that the kernel is like a library at this point. UAPI is like a libuAPI, if you want to call it. And so then you have to consider all the use cases of where it can be put. And I think the other thing that's going to show up here, if we get to it at some point, is how do you define macro values? Are they enumerations or not? If those things get included into C++ programs, then those C++ programs can change the name mangling of that thing in a C++ program. And so whether it's an enum or a macro matters, whether it's assigned or unsigned matters, because that changes name mangling. And so while UAPI is all C, it can get included in C++, it can get included in Rust, it can get included in WASM in theory. Like all the language runtimes suck in basically what is effectively libuAPI. So
interesting. All right, yeah, thank you. We can discuss that more.
So for the multi-arch stuff, like I know the kernel for some reason years ago took away the full all headers install target that was there. And so like we're using scripts now to generate our kernel headers package and for all headers, but we can do that without having to pass a cross compiler. And so I'm kind of wondering, like maybe we could make this script where it checks all arches and doesn't require a cross compiler to do that.
Yeah, so the issue there is we are actually compiling the header. So basically what we're doing because ABI diff operates on binary files. Right. So to do that, to generate the binary file with the dwarf necessary to have ABI diff process it, So we basically pass in a dummy C file that just has return 0 and then
That's right. I was gonna say, yeah, you need the cross compiler because so Doji is on my team at Red Hat, but you can't check the headers by themselves. You actually have to try to use the things in the headers to then get a binary artifact that you can then compare and check because the headers need to be processed. That you need to go through that whole step. So you need a cross compiler to do all this. And so if you do all the headers install, you need all the cross compilers, which is okay. It's just up to however you want to deploy the script.
Yeah. So like in our case, if we're checking an ARM64 target build for that kernel, then we'll do the UAPI checker script for that. And just for some context, at Qualcomm, we are using this as part of our CI process for changes coming in. So yeah, if something comes into kernel platform, we run the UAPI checker and we can go yell at people if they break. Right, so here's another example, changing a type in types.h. So changing poll _t to unsigned short. In this case, you run it and it flags something in event poll.h. And this is kind of notable because that's not the header file you modified. So this is another reason that we have to go check every single header file in the tree, not just the ones you modified. They can cross depend on each other. And you can see here the script also says, hey, I noticed this .h file didn't change between the revs, but maybe one of these includes did because something broke. And another reason is you can have a change like this. So if you comment out the terminus.h from kbuild, then it doesn't get installed by make headers install, and boom, the header's gone and you've broken somebody. So yeah, it'll report any UAPI removals as well. You can check large swaths of history by passing in -b and -p. So you can look between 6.1, 6.0 in this example. And I'm not printing everything here, but the script does flag 37 things as breaking between those tags. And one thing to note here is the script has no understanding of your intention with your changes. So like I said earlier, the kernel does go and refactor things. The kernel does go delete unused interfaces, and that's perfectly valid, but the script doesn't understand that. So I guess before we move on to the next script, any other general questions about the script?
A common pattern in UAPI will be adding padding at the end of a struct of a different type, and then as you need to extend it, you will remove the padding and replace it with variables of concrete types that you need. What would happen with the script?
Yeah.
What would it do?
So in our earlier revisions, those issues got flagged, but we did work with Doji and the LibAbigail team and added a new suppression for that kind of situation. So in the latest revision of the script, we have basically a big list of regular expressions, and we say if you're expanding into any of these named fields, then we consider it a safe change. So it's like padding, reserved, those kinds of things.
I just mentioned that the suppression in LibAbigail is even extensive enough that so in libc, we have some structs which the first X number of bits are public and the residual number of bits are private. So for example, the link map structure has some fields that users can rely on and some fields that they can't. And while the checker can see the definition of all of those, you can have suppression lists that are even as complex as these things don't matter if they change past this number of bits. So, but I can't come up with any examples in my head that are that case in UAPI. I think everything that we expose is the user can see it, and if it's defined in the header, then they can access it.
Okay.
One other thing I was wondering about is you were saying that there's 37 differences between 6.1 and 6.0, and that some of them are intentional or at least yes, they're breakages, but it doesn't matter. It sounds to me almost like if this is adopted more widely, that labeling whether or not something was intentional or not might be a good idea, so that this could be used more long term. And I don't mean with your tool, but actually in the source code, where people could basically say this: we intentionally have changed the UAPI for these reasons, that you could then consume. Of course, that's a bigger piece for the kernel community. Say again, sorry. When you delete, I delete your whole driver. Then you can't do it. That's true. It's true.
I mean, yeah, you can put it in the commit message, so it's still there for posterity, and there's a way to verify.
Yeah.
The point is that as long as that's marked, that could be kind of interesting. Sorry.
We have you talked to the kbuild people that 0-day bought at Intel?
I have not.
I feel like that would be the right way to do it. They generally report things once, and that's how I do stuff. I consider one report, and then if you fix it, good. If it's not, it's like you've seen your report. Normally people fix things, so we're pretty good about that. Try not to nag you about stuff, which is a false positive,
Yeah. Okay. Yeah. And yeah, this is generally useful as kind of a tip off to a reviewer, not necessarily the end all be all of what is compatible, right? So that's kind of how we're using it internally.
And how will the script handle implicit padding added by the compiler? If the struct is, for instance, 46-bit aligned, and you have a 30-bit variable at the end, field at the end of the struct, and then you have another 32 bits of padding. If you add something in that padding, which what does the script even handle it? Or?
Yeah. So I believe ABI diff in that case, if the size of the structure doesn't actually change, then it doesn't report it as an incompatible change. But if the size does change, if you happen to go over the padding boundary, then it would.
But
does that make sense?
It can be incompatible on different architectures, like if the alignment. Is
it would check with whatever you're compiling with.
Okay.
Yeah.
As I say, LibAbigail is working on the dwarf data for the compiled test application that basically uses the headers And so if that changes in a way that's observable by the program, then it's an ABI issue.
LibAbigail, somebody talk to what it is exactly?
Yeah.
I guess you're on the team.
So Abigail is a ABI serialization analysis library, and we implemented it ourselves because in Fedora and in RHEL, Abigail gets used as part of passes for inspecting the ABI artifacts of built packages and whether or not those ABI artifacts are changing. So, for example, for glibc, we have a public statement for an application compatibility guideline for RHEL, and level 1 applications are ABI stable across 3 major releases of the OS. And so we use LibAbigail to do kind of look at ABI artifacts and how they're evolving between, let's say, like RHEL 7, RHEL 8, and RHEL 9. You should be able to take a RHEL 7 application and run it in a RHEL 9. So this is a great use of like ABI serialization and analysis to then decide between these releases how are things going.
Mm-hmm.
So yeah, if you look up LibAbigail in Google, should pull up the project.
Yeah.
Okay. I work in safety critical environments.
Mm-hmm.
And big, huge can of worms that you didn't intend to get into, but developer author intent is a big issue. Having meta information associated with that, being able to understand what the intent of the author was in a parsable way, like SPDX, is hugely important. We can't fly things in we call level A critical situations, high hazardous situations, because the Linux kernel doesn't have actual design and architecture associated with it. I have to show the FAA design and architecture, and I can't do that. There's too many lines of code. So Kate and I were just talking about that. We do need some sort of meta information associated with, ideally maybe even a standard, I don't know, associated with author intent and design level requirements pushing down.
For 10 patches of power, 20 cars a day.
It's exactly what we said. I don't know the right answer to that question.
There isn't an answer. It's no.
No, I'm serious.
Yeah. The question is, subset where it counts, which is the API.
Can you use the mic, please?
We want to put Linux in places where it doesn't exist right now.
So, I mean, you're free to use Linux for whatever you want, but you're not free to tell us how to create Linux. And we can't impose additional restrictions on our already overworked maintainers to meet an arbitrary single government requirement.
Not at all. What it has to be, it has to. I agree with you completely. And anything that's done has to improve the workflow for everybody.
As someone who is well versed now, unfortunately, in different governmental regulations in the different parts of the world, there are conflicting requirements and uses to find something that's going to work for everybody. I mean, you're going to tell the country of Taiwan that, yeah, you know what I mean. Anyway, so but that is independent of this. So I mean, UAPI changes are wonderful because we don't want to break them, and we remove them. But that has, I mean, we can intentionally do that, but that is not a functional of the code. API is not a function. How things work.
Yeah, but from the API perspective, if we can basically have more visibility as to the intent behind the APIs and have that documented so people don't keep getting asked and asked and asked, we actually have a path forward here.
Okay, so we do have documentation API, and we have tools that check, which nobody seems to run, if we are, when we do add new APIs, that they are actually documented there. So if a group were wishing to document everything, you can run the tool today, see all the holes, and start documenting. We'll never turn down that documentation. So we have the tools. There's tools already in the kernel for that. So there's tools in the kernel to check the API of an installed system to see if it's all documented or not.
Yeah, I actually get to some of that.
Okay, cool. I mean, that's a great tool. But I mean, that's independent of changes. Like this is, you're checking structure sizes here, which is a different.
One second.
Yeah, Nick.
Thanks for the stats. Even just between two releases of Linux, like 37 is much higher than I would have expected. That 0 of those are a problem for any user is surprising to me.
But I think that what they're talking about here is if you refactor, like we do this all the time in libc as well, you move, you break structs out, you put them into their own headers, you then reorganize, and you're constantly cleaning. And yeah, exactly. You're constantly cleaning the headers. So maybe to Kate's point and Chuck's point is that like often what you want is a change, a commit that also adjusts the suppression list. It's a little dangerous because it's dangerous because it's a closed loop change, and so if you make a mistake in both places, you don't detect the ABI issue. But intent can be documented in some way that if you have a second suppression list, if you have a suppression list and you're able to check the suppression list, and then you just make sure that the change matches, or you describe some way why it's ABI compatible. But again, it is extra work, and people do have to agree that work has value.
Yeah.
So I think it's valuable as a libc author, right? Because every day I'm just git pull and I build new headers and I build new libc against the new headers, and I'm constantly looking for breakage in that way. And UAPI is what I'm always looking at because it's what we need to use in user space.
Yeah. And I'm curious, do you have data across multiple Linux releases, like a histogram of like 37 this time, but how about the next time? How many were there?
Yeah,
like,
I don't have that today, but it'd be easy to generate.
I'm almost picturing like, it would be nice if we had some metadata file or something that said like, for each breakage this tool identifies, has someone looked into, is it problematic or not? And then that's something that the script uses to suppress things. So you're not suppressing every -i, because some are bad and some are not bad. So instead you have a way of breaking out, oh, well, when this field changed in this struct, it's okay. And the tool suppresses that in the future. But if there's, 1,000 UAPI breakages a week, it's not sustainable to maintain that kind of metadata.
Right.
If there's few, which hopefully there are, maybe it is more sustainable to have a list where people have signed off on each one, either saying, oops, or nothing to see here.
Yeah.
Anyone else?
No, great. Yeah, and please do, there's a link to the slides on the presentation. Yeah, please do follow the links in there and participate in the patch, and we can get discussion going there too. So in the same patch set, there's also this script, check module params. It has a very similar command line interface. The logic is much simpler. All it does is essentially grep for module param dot star, and then looks at your args, and if anything changes, it'll flag it. And that's really all it does. So it's helpful to have in our CI system as well for inexperienced developers who might be changing something inadvertently. But yeah, not very impressive. So now this comes up to sysfs and procfs compatibility, and for this, we don't really have any tooling. We don't have an answer to this problem. So part of the reason I'm here giving this talk is to solicit feedback from all of you experts about what we can do about sysfs and procfs. Because basically today, we have read and write from these files, and that's the interface. So there are plenty of ways to break user space by changing your sysfs or procfs files. So I'm open to more discussion here. If we just to kind of get the juices flowing, as Greg was saying, we already have sysfs and procfs files in documentation/ABI, and there's already a Perl script that can go in there and parse all of that documentation.
Great example.
Is it?
Richard Purdy is a part of the Yocto project and open embedded. So
I picked it at random, so I'm glad it's good.
Sure, it's random.
And getabi.perl, it has the ability to look through your documentation directory, and it'll look through your running sysfs nodes, and if it sees any sysfs nodes that aren't documented, it'll say, hey, go document these. So we kind of already have a little bit of machining here. So I was wondering maybe this could be extended and have something kind of similar to like device tree bindings. So if the documentation in there kind of becomes the API to SysFS and ProcFS, maybe we could write some automated tooling that could, it could generate test stubs. It could potentially perform static analysis. I don't know. This isn't a very fully baked idea. I'm just kind of throwing it out there. So I don't know. What do folks think about the SysFS and ProcFS compatibility?
I'm assuming.
You put your laptop down, man.
I'm gonna pay attention. I mean, SysFS's goal is you can, if a file is not there anymore, that's not a break. That's why it's one value per file. So proc, we had the problem of fields that you had to parse out of a static file. So SysFS goal was to, if the file isn't present, that means your user space code better handle that and move on. So removing or adding a SysFS file is not a breakage. It's actually by design.
Okay.
Now the trick is what does that file contain?
Yeah.
And people argue about that all the time.
Yeah. And if I write a 1 or a 2 to that file, what does that mean?
Exactly.
Yeah.
But I mean, we have the document. I mean, it'll go back to we don't break the API if you notice. No, literally, that's the rule. And then if you notice, we work around it, and sometimes we do we will change this in 4 years because we changed user space today. We know now we can change it in 4 years because nobody will notice anymore. And that's a valid way to do it. So it will show up as, oh, this is a breaking change, but we know because user space can handle it.
Yeah.
So encoding that is hard.
Yeah. Yeah.
Say, checking for breakage in ProcFS, of course, is also hard because the files themselves can change. So what's in it, the format, so it's yeah, no, of course, yeah, no, exactly.
But people keep wanting to add things to them.
Exactly, exactly.
But I mean, you do have the Torsten's doing the regression stuff upstream too, right? So we push stuff out. Obviously, we'd rather it not get out to users, but when it does get out to users, a lot of those regressions now are being tracked well and being handled by that project. So
yeah,
things get reverted. We're seeing it. It's just, it's not the ultimate solution, but at least it's helping.
Yeah, and testing is a great way to catch a lot of these issues. Yeah, we're just trying to find an answer that can help maybe before it gets out there. Yeah.
Okay, we've got somebody I think on the stream. Rob, do you have a question? You might have to unmute.
They are unmuted.
No, he may be hardware muted on his mic or something. We can't hear him.
I can see if.
Oh yeah, would it be going blue on the?
I'm not sure. Yeah, can you ask your question in chat? Is that okay? We can't hear you.
Yeah. Okay.
Technology is hard.
It is.
Just always asking the question. Anybody else have something they want to add? Yep. Oh, sorry.
So if I'm building a Linux distribution, how often should I be running this sort of tooling?
Every time you upgrade your kernel, I would guess. Every day.
Yeah.
Okay. I mean, that's a fair answer because I knew you'd mentioned that there as well. But I'm just curious.
Yeah.
How closely you should watch for ABI changes.
Yeah.
And I can certainly see them sliding in funny ways.
Yeah.
Knowing what I know about how people build Linux distributions.
And I'm not sure about your process. We run this on every patch as it comes in to our kernel. But if you're a distro maintainer, yeah, I would agree. Probably every time you upgrade your kernel, you could check the sources there.
I was going to say the same thing. I think I channeled Don Zickus here for the RHEL kernel team as well, which is every time you've got pre-commit CI that should be running this to give you a green, yellow, or red, right? Depending, I didn't see you have any warnings, but there are ambiguous, which can end up in a warning category for someone to review versus red, which is like you definitely know it was an ABI issue.
Yeah, that's true. Maybe we can change it so that it's like a warning condition instead of just
success,
suppressing
warn,
it with
fail,
-i.
and warn someone should inspect it. But Yeah, so I'd say every time you build a binary artifact, there's either gating CI or before you get to that pre-commit CI, I'd say you'd want to run this.
Okay.
Yeah.
Rob actually just posted here. He said, just want to say he was thinking the same thing for SysFS docs. Rob also saying he JSON schema is kind of the hammer he uses now for this, and Giuliano, I'm going to mangle your name. I'm sorry, Giuliano.
Yeah.
There we go. Is saying inter-array enum max changes should be considered breaking. So yeah. Anyway.
Yeah.
Yes and no.
Yeah.
I mean, that's kind of what it's there for, right?
Yes, it is a breakage if user space used it. No, it has to be there because the kernel needs it. Right. And we can't split unless we define it. We just C requires you to put it in the same spot. That's the hard part.
Yeah. Yeah.
Kernel needs to know the max. It's a mess.
Yeah. Okay. That's an interesting edge case. I'm sure there are a lot of different user space edge cases that we're not considering here. So yeah, happy to hear anything that should be flagged and isn't. Yeah.
As far as how often this should be built, run in a build system, I'm not entirely sure that that people are going to run this on every single build of say a Yocto project build if the kernel hasn't changed, for instance. In some cases, people will wipe out their entire build and start over again. Checking the UAPI changes on every single build I can imagine, is something that not everyone would want to do every time. Although I agree that it'd probably not be a bad thing to do. But if you're making changes to the kernel, absolutely.
Yeah, for some context, that on an 8-core machine, that takes about 15-20 seconds to run.
Yeah, that was just the question.
Oh,
how much is the impact?
Who cares
then? Because if I burn like 10 minutes on compiling the kernel and it's 10 microseconds, then I'm gonna be like, who cares?
Yeah. No, it checks them in parallel, so more cores help. But
Okay. It says, or you can stop your users using arbitrary things in the UAPI. Not sure how you can do that, but.
Yeah, that is trickier.
What was the question?
Yeah, down here.
You can stop your users using arbitrary things in the UAPI.
Oh, mine doesn't.
I was going to say, I'm not sure you can.
No, it says you can't.
You can't. I'm sorry. You can't. I'm sorry. Thank you. That's an opposite.
Yeah.
Sorry.
When we know we're going to break the API, we search the Debian code search to see if it's actually used or not. And we use that as our reference to see if this is going to be okay or not. So that's how we do it. Like I've been changing a lot for the serial ports and stuff like that. We're seeing what is actually being used. And when we drop protocols and when we drop other stuff.
Yeah.
So that's the best we can do, because we can't see all the close, but Debian is the world. So I mean, it has the world contained in it. Everybody else is a subset of Debian. So.
Yeah.
Well, we have a big world.
Couple more minutes left, and any last parting shots or things that people want to add?
Maybe it's totally unrelated, but I just this metadata stuff. I was just wondering, and I don't know enough about the SysFS internals, but any sense of possibly using extended attributes to just put metadata about each file that's there, so that you could possibly have version number. You can extract straight from SysFS and probably even generate that, part of as a kernel artifact.
We do not allow help files within the kernel.
Okay.
It comes up a lot. It's like you read this file and it's going to tell you what it described. No, we don't. What we do, there are some SysFS that do have, this is going to be one of 4 options, and it shows the 4 options and shows the current selected one. But other than that, we don't want to do extended attributes. Yeah.
Has a question. I think he's raised his hand on the talk.
Oh, yeah.
Do you want to come on camera and ask your question?
Yeah.
Oh. He's trying to connect.
Yeah, I heard.
Seems like we're having some audio problems. Again, if you want to put that into chat. Oh, here we go. 1 second.
Does it make sense to show a commit hash to that introduce the breakage? Just idea. So, you may need to run git blame to just detect the commit hash, because we need to check the commit log that this is just a breakage or just something intentional change. Or
You bisect the breakage?
Can you bisect the breakage?
No, not bisect. Yeah, git blame, because you change this field in the struct, then probably you may want to check the commit message, why this field was changed. So just idea. So it might be useful
So
just to show the commit.
in general, you could. Yeah, but yeah, Masahiro is right. If while I was developing this, if I find something in between two long swaths, I'll do a git blame on the changed file and try to figure it out that way. That's generally pretty fast. Yeah, it could be.
Yeah, just idea.
This is really good. I mean, I really like what I'm seeing here. I would say one of the things you're probably hearing, maybe mostly from me, but this is a heuristic at the end of the day. And there is a desire to see similar levels of compatibility assurance in a lot of different open source projects as well. So, definitely keep going, but I think there is a larger need here that is not being addressed.
All right, great.
All right. Well, that's actually time. So thank you very much again. Thank you very much, John. It was a great talk. Great things. It sounds like we've got a lot of interesting ideas and other stuff.
Come find me in the hallways and we can discuss more.
So I guess we have to all implement this in our build it systems by net for next year.
Okay, thank you very much. Our next speaker will be Bruce Ashfield, and he is going to talk to us about building kernels and what your outputs are and things like that.
Okay. All right, we're going to start our kernel talk now. So yeah, anyway, we're going to pass it off to Bruce. Right after this, of course, is when the break is, so we'll look forward to that. But Bruce, you're between us and the break, so
I can cut mine short.
There we go. No, I'm sure we'll have lots of arguments.
Or not, we'll see. Is it the page down? How do I switch slides? Oh, there we go. One or the other. All right. Test. Yeah, that's great. So yeah, let me introduce. I'm Bruce Ashfield. I work for AMD, but you can't, and formerly Xilinx/AMD. I am not here to talk about what Xilinx and AMD really do with the kernel and build system, because that's actually other people than me. Full disclosure, I have been maintaining the kernel in the Yocto project since it started, and maintaining distribution kernels since roughly 2006. So I've been at it for a little while now. And my talk is mainly some points. I'm going to reference how it's done in Open Embedded in the Yocto project, because of course that's what I know and what I do daily. And other than that, it's sort of open questions and to see if anybody has thoughts or how they've solved the similar problems that we run into when we're doing our kernels. So the one thing that I will say to start is as I've learned many, many times, You absolutely cannot keep everybody happy at the same time. So either your build is too slow, your build is not reproducible, your build isn't hashed, your build, the developer shell, the debug cycle isn't as fast as somebody wants it. And that's all the things that you're sort of about. Or the build artifacts aren't in a place that can be distributed. They're not assembled into the right type of image. Or U-boot isn't synchronized with it. Or, there's, I have a binary blob and a bootloader and my module auto load and my API. So these are, they're just absolutely, as far as I found, anybody tells you that they're solving all of these problems at the same time and everybody is happy, I think they're either lying or they haven't shared their build system with the rest of us. And either one of those is probably not a good thing. But yet we try. I don't know, that's probably not readable to the people in here as I've been watching them, that I should have figured out how to do bigger fonts. In fact, I can barely read it on the laptop screen here in front of me. All of this illustration was supposed to show is that, you have, say, maybe core aspects of your build system and things that you care about. And those are the pillars here. So, how do you configure the kernel in a way that matches different types of hardware? Because I come from an embedded background. So we're not talking about an all yes config, all mod config, we're talking about lots of different configurations that vary based on not just the board, but a carrier card on the board, or dynamically delivered hardware if you're using an FPGA-based platform, right? So is the configuration a core pillar of your build system? Is it reproducibility? Flexibility, meaning I can build lots of architectures, many different types of kernel image, one for performance, one for debug, one for whatever. Is it, oh my goodness, that one's really small. Maintenance and support. Image creation and build speed, which is actually the one that I would say I really can't keep everybody happy at the same time. And of course, is it associated with maintenance and support would be, how do I debug the kernel if I have a problem? And of course, on the top of that is the outputs, your kernels, your modules, your DTBs, your user space configuration, UAPI headers, because as part of what we do in the Yocto project is I maintain, along with the kernel upgrades, I produce the Linux libc headers package, which is the export of the UAPI headers for every release that we synchronize it with the kernel. Is there firmware, is there debug, and nowadays is there SBOM, is there other information that's coming out of the kernel build so you can trace these modules and everything back to the source file. And of course, at the bottom, it's, what version are you building? What's your release cadence? Where does the source come from? Because as soon as you talk about, especially embedded kernels, you'll immediately find the forest of different kernel trees that are of various vintages and various maintenance quality. So yeah, these are the sort of the inputs at the bottom going through the pillars, and then those are your outputs at the top. And, trying to balance those within a build system is not always easy, or never easy. There you go. Those are that summarizes down to the ins and the outs. Seems pretty simple: source, configuration, and policy. Some security information, whether it's keys or provenance or something, that's evolving nowadays. And the outs are, I would say, your kernel and your supporting binaries, your boot artifacts, whether it's scripts, device tree, firmware. We have different packages and images. I have something about that because everybody packages things up differently. And then the outputs, the traceability, I would call it, in your licensing. So that's your debug, your SBOM, and your CVE information. So simple. And then the extras. And this is what we run into as doing the kernel as part of a build system. Every time I do an upgrade or an uprev for Open Embedded in the Yocto project, there's a set of user space packages that I know will break and that I have to fix before I can get a new reference kernel into the project. So, really tightly coupled would be the compiler and the libc headers. I have to upgrade those and make sure, and then build the entire user space against those headers to see if anything broke. And it's not in the sense of the last talk. We're not really concerned about ABI issues. Literally, compilation failures pop up on several packages quite a bit. Whether they're poking at files they shouldn't be or not, that's a different question, but it breaks in. I can't do a kernel until they're upgraded, until they're fixed. And then there's things like LTTNG, perf, and system tap that are part of the kernel source tree, if you will, or very close to it, but they always need to have their user space component revved at the same time, again, before I can actually put out a new kernel version as part of our build system. There's no way to do one without the other, or it's broken and it doesn't go in. And then we also output we generate SDKs. The Octa project in OE has something in an extended SDK. We have different ways that you can build out of tree modules against it, on target, off target, and the build artifacts. And then, we produce if you're familiar with how Open Embedded does things, there's shared state and different things that will accelerate your next builds. And because of the sheer volume of the kernel source, how much there is, years ago, for all the things that needed to reference, we do the compiler the same way. There's a shared kernel source directory that it has to get copied to, so that's produced and it has to be valid. And of course, we then produce everything from containers to VMs to unikernels. So those are the extras. So, that's all that you have to worry about when somebody says, why don't you just jump to the next available kernel? And in fact, we got a little bit surprised in our just past release where the kernel I was planning on releasing got EOL'd before our release, even though we had gone through all of this validation. So we had to very quickly jump to 6.5 and do about a month and a half's work in 6 days. So we are getting better. We can actually get through most of this stuff in 2 or 3 days now, when it used to take a lot longer to validate the system. I'm sort of, presenting right now for a lot more questions coming up, but if anybody does have any comments on that, if I've missed an important output or something like that, please do interrupt me and let me know. The way that I would say the real juggling that comes in that first image that I did. All right, I wasn't sure if you had a question or you were just getting the cube there, Phil.
I'm getting ready.
All right, good.
Is
the persona, here's the question. It's like, are you doing some kind of release build? Is it, release load build? Are you talking about a production build out of your build system for a kernel that will be formally released? Or is it somebody who's just sitting at the keyboard and they're doing development, right? Whether they're doing kernel development or user space development with some sort of interface between the team, right? So are they in a build, right? That's another distinctly different persona, right? It's absolutely different. Is it somebody that is just integrating, they're pulling things together, if you will, like an operating system vendor, right? Are they pulling the different bits together versus even developing? They're not doing any development, not doing debug, but they're taking your tree and they're integrating it into their own product or their own images. Are you then the person that integrator might hand it to? Are you the distributor? What you need out of a kernel build in a build system would be different yet again. What are they providing? Does your build system produce what they need to be able to hand it off to somebody else? And these days that would be go back to my licensing SBOM, all that stuff, right? It has to be output as part of your build. So they have a way to verify with whoever they're handing it to, that they know what it is and where it came from. Or are you just a community member and a contributor and you're working on a new SOC and you want to get support for it, or you have a problem and you're sending a patch, right? And there's probably more. Those are just the ones I came up with thinking about it for 2 minutes, and I'm sure there's more. And my question is, in your build system, do you have a primary persona and target, right? And does your build system optimize for that kind of workflow? Because I can tell you, working in Open Embedded, that we don't optimize for this developer guy who's doing the build and debug cycle within Open Embedded. I don't know if anybody does build and do kernel development in OE. I'd be interested if you told me that you are actually using BitBake and how you're using the flow that we have to do maybe your quicker development. Because in my experience, kernel developers just want a cross compiler, the kernel source tree, and then they want to get the images quickly to a target somehow and to test it. They don't want any overhead at all whatsoever from a build system, parsing files generating packages and RPMs and release scripts and all this stuff. They don't need that, right? So, and that is what you would get if you do bit-bake virtual kernel in the Okta project. You're an open embedded. You will get all that extra stuff, whether you are planning on using it or not. So, you know, that's my big question is when you're worrying about this, it's like, do you have somebody in mind that you're trying to, a persona that you're worried about? No questions? Good. I'll just keep going.
I had one question going back to the UAPI stuff. You said that when you upgrade, you basically just build the world and look for failures. Should you be thinking about doing the UAPI script and looking at those just to see where the changes are ahead of time?
Yeah.
To try and make that loop a little bit quicker.
It's something we could do. Yeah. It's literally Bruce knows that 7 packages that break and I go build them and then attempt to fix them.
I mean, it sounds like you know which packages are going to break most likely, but this I think would maybe make the world.
But it would help if I'm not doing this anymore, the next person might not know the 7 packages because they've been doing it for 10 years now. Yeah. And I was saying to John in the back, the difference a little bit with the way that say kernel in a build system from that point of view is we're not doing kernel development in the sense that when we jump from, well, I do every kernel as a dev kernel, then we do a release. So every version is looked at some point, not in as much detail. We're doing it from 6.4 to 6.5. So if I have a UAPI header failure, you then really need to bisect the 7,500 commit. Like it would be interesting to know that there was a UAPI failure, but really it wouldn't tell us where it was yet till we went in actually when we would have to then have I would still have to do the follow-up and do the bisection.
I mean, it might also help people deriving kernels and maintaining their own kernels and giving them warnings when they added a driver that has an unstable API.
Well, yes, especially in our world with the evil vendor trees and
and the people who add their own patches
that we could publish literally the UAPIs. Like when I validated 6.5.4 with the Linux libc headers, that's your reference for what we built for UAPI. And if it changes from that, whoever's handing you their kernel tree has done something that you might want to look into. Or we could even just add a task in our build system that you could just run UAPI check against whatever your tree was, and we could have a reference somewhere. There's probably something that we could do there.
Yeah, I mean, I'm just trying to think how you would integrate this tool into a build system to give you useful information that you could do something with.
Absolutely. Yeah, like I said, my thought was that the integration would be easy, but how do I use it to find the commit that caused the problem, right? And that I wouldn't want to leave you just that it's broken. You want to be able to figure out where it is. So I just wanted, so the next thing I wanted to summarize before I got into more questions was, in case people aren't familiar with how we do the kernel and open embedded, in the sense that it is an absolutely flexible provider model. It's virtual kernel. Your kernel recipe can provide that, and the rest of the system keys off that as part of the build. And so that means that your sources, your patches, your configuration, they're yours in your tree, and however you want to provide. There is no one golden tree. I'll talk about the reference kernel in a minute, but that is not any kind of golden reference or single provider, right? But that prevents us many challenges throughout the ecosystem, in the sense that I keep talking about, that's why when we do a release, we say, this is the reference kernel, this is the reference kernel version, and these are the Linux libc headers, and blah, blah, blah. And if you are in that same version cadence, it should be pretty well off. But that's the best we can do for the most part, because, and in particular, it causes us trouble with tightly coupled to, like we package perf as part of the kernel build system work. We can't actually ever patch it if there's a problem, because we don't know what kernel version you're building, what kernel tree you're building. So if you look at our perf recipe, there's all kinds of sed operations to change, to fix problems on the source code if they're there. because we can't patch it. So those are the type of challenges that your build system and the providing a kernel may, and maybe somebody will say, another build system, they may just take a copy of the perf source so they can patch it and maintain it like as they will. But then we would have a version of perf that doesn't match everybody's evil vendor kernel versions.
I think you can use the latest version of perf. It's supposed to be backwards compatible.
For the most part, yeah, but we have, it's just such a, like in our world, it's just such a drastic different set of kernels that we've never tried that. But we do that with the libc headers. Like I go to the next major kernel version release, and we actually have warnings in all of those files that says do not provide your own libc headers, because if you're not using our version for older or newer, they're compatible, right? And there might be something we could do around perf. But nowadays it doesn't cause us nearly as much trouble as I would say it did 4 or 5 years ago for breakage. So, but there'll be another tool that gets integrated that causes us another similar issue.
I mean, tools tends to break once or twice a year in my experience from user space headers, and it's always during the merge window, and it's the tool needs something new that is now in kernel headers, but because like by default like RHEL builds the tools as part of the kernel package, you build at the same time, excuse me, it doesn't work. But because like Fedora tracks upstream in the way we do, we build our kernel headers package separately so that we can get around that problem. I can build it and then use it as the new package as the build dep for building the tools, and it's solved.
Yeah.
Can I just ask a quick reference question here? How many people here work with the latest released kernel? How many people work with blankety blank vendor trees? Okay, so it's about 50-50.
Much pain in the room. No. And the other thing that we've run into with the complexity, if Richard was here, are you listening, Richard? Somebody tell me if he's listening.
I don't think he is.
That both of us are actually quite afraid to go in and touch the kernel packaging parts of Open Embedded, for example, because there's a lot of complexity in the different types of kernel, especially in embedded, the different types of output formats and the way you package the kernel, whether it's a fit image, whether it's is it signed? And anyway, and the point is in ITRAMFS, and we end up with a recursive build where we're actually building the kernel for the ITRAMFS, but it's not the one that's booting because there's a pivot root, and everybody goes in and there's conditionals all through the build system, your build system to handle all these cases. And are they signed? Are they? It's like anyway. It's how are the kernel modules packaged along? So the multiple output types, in my experience, if you live in a very single architecture worried, whatever, maybe your build system is great for optimizing for that. But as soon as you live in like a multi-platform, multi-tree, multi-architecture world, there's a lot of complexity in a build system to try to handle those output formats. And every time you change it, somebody, yes, does pop up that you didn't even know was building it in that way. So there's that. This is what I've been hinting at. So if you don't, what about a reference? How can you do this in a world in a build system that maybe doesn't have one kernel where you can switch your kernel out fairly easily? And what about a reference? So this is what we do in the Yocto project and Open Embedded, right? So we have, we do have a reference kernel that follows the release cadence of the Yocto project. So twice a year, we release basically, there's a dev kernel, which would be the latest at the time we released. It's sort of experimental. There is a release reference kernel and there's an LTS kernel. So there's 3 versions in every release. So that's how we sort of solve the problem. And the leading edge of those versions, that's what drives us to make sure that the kernel is part of the build system. All the tools and everything does work with the latest. So that is what drives sort of, and those tightly coupled packages. And it allows us to test the workflows, the personas that we're talking against the tree. So it drives those kind of changes that we have a reference kernel. And, it allows us to test more easily some of the, we have different flavors of the kernel, whether it's real time or tiny or standard developer or whatever. So having a reference in the build system, whether you expect somebody to deploy it either in production or on their particular board, is a good thing because we need it to drive these things as part of the build system. As we get more and more along to the utopia of all upstreamed patches and generic ARM64 images and generic x86 images, it will be easier to have fewer of the vendor trees, and maybe the reference will be even more useful at that point. We don't need that. How am I doing? I don't even know how I'm doing for time. Good. This is not interesting. We don't need this. This is all the little bits and pieces that are underneath the how the reference kernel builds in open embedded, but we don't need that. So this is the more discussion part of my presentation. That's about all I prepared for, sort of the problems and what open embedded does and things like that. So it's sort of the challenges. What I'm saying when you're doing kernel and build system, and AK, they're also open questions, is, you know, it's the infinite different entrenched workflows, right? Do you care about the infinite number of entrenched workflows for people to do configure, build, deploy, boot, debug? How do they manage their patches? What do they like to use? How is it tracked, right? So, you know, do you pick yours and run with it, or do you allow variation in the build system so they can use their entrenched workflow? This is, we already covered this, but it's worth saying again, especially for the recording. You know, there's many different kernel source trees out there. Yeah, we should all be using upstream kernel.org, but reality, especially in embedded, is that's not always possible. And you end up with hundreds of different BSBs, and how do you manage to end of life? Because, you know, you'll have somebody pop up trying to build their 2.6 kernel, literally still, with open embedded, and trying to find
the best kernel.
And trying to ask us if we can still support it as part of the build system. And there's just things that have moved on, and there's no great way to do that. So yeah, how do you EOL a BSP in a world where the kernel is completely flexible, right? Perf's not going to build. All of these things that we key off of kernel source aren't going to work, right? Another challenge, again, like this is probably because I'm an embedded developer and that's my world, is that, you know, we part of it's not just a kernel, and a kernel is part of the build system. There's inconsistent quality and testing that's done on that tree. So you don't, it's not even that this is not a question of provenance or SBOM or knowing where it's from. It's just to even boot test this tree, you wonder sometimes when the serial port doesn't come up, or, you know, something like that. So that you have no idea, right? So the challenges are, how in a kernel and a build system can you get a feeling for the quality on the way in? And that usually comes some sort of, we have like the Octo project compatibility programs and different things. That's the best that we've come up with for a way to, but maybe there's a way you should build it and do some automated testing. And if it passes X things, then the quality's there, right? I don't know. And then, you know, how are you delivering? And this is a particular, if you're not using, say, the Yocto project reference kernel, or you're just a reference kernel and you've done something else, how are you getting support or security updates? Because we all know vendors don't tend to come back and do even stable updates to their tree, much less CVEs and things like that. So that is a problem. And can your build system handle doing those updates?
I will do the evil thing and say that especially the testing, the inconsistent quality, does not have a technical solution. Because the one thing that we need to communicate to people who are in power to allocate resources to actually do that, they need to be convinced that ensuring this quality and doing the testing and all of it that comes with it provides value for their company, for their business, for their future, whatever. Because if they are convinced, then the rest will follow. If their objective is to just get it out of the door so we can sell some system on a module, then it will never happen. It's a social / psychological problem, and not something that can be technically addressed.
So my build system's not going to fix it.
I can't help thinking that in civil infrastructure, reliable systems, critical systems, aerospace systems, this is actually pretty important. What level of testing and assurances are you looking for? Open question.
I mean, you talk about personas, right? Like, and
I am always talking about beer.
I mean, I wish Greg was still here. I didn't want him to think we were trying to push down a bunch of FAA specific rules. I'm really talking about like what you're saying, the persona. I would love to be able to have, I mean, I have an automatically built SBOM now, right? I have an automatically built license list. I can show a graph. I would love to be able to have an automatically built test report. Those kind of, I mean, there's P-test, of course, right? So all that kind of stuff that then those are the personas I can hand over, and eventually it's just hand this file
It's an
over to
output of the
regulator.
build system, and it's something that, yeah,
exactly
goes along. Yeah.
Yeah. So basically auditability, anything that happened, I should be able to show evidence of that.
Absolutely. And what if there was no testing? Well, it says no testing, and at least you know there was no.
Correct.
There was no testing. And actually, that's one of the things I have in my future slide. Luckily, let me edit this while you're not looking. So yeah, and the other, so if we continue on that, the many different, the more challenges of a kernel coming out of a build system are there's many different ways that kernel can be consumed, right? Is it an SDK, meaning you're building out of tree modules against it? Is it only a binary without source? It happens. Where can the kernel be rebuilt? Is it only in the build system, or do you actually want to provide packages as part of your output where they can rebuild the entire kernel on the target itself, right? So that's the question. That's some of the questions that the kernel as part of a build system have to answer. And the answer is we actually, in Open Embedded, for example, we provide the ability to build out of tree modules on the target. And if you wanted to rebuild the whole kernel, we can't currently do that unless you've found my patch in Bugzilla where I actually package the whole kernel source tree. So you could do that, but it's not, we don't do that. So that's how it was answered, for example, in Open Embedded right now. But I'm sure somebody somewhere has got a BB class and a layer that I don't know about that's packaging it, but that's the beauty of a build system that's extendable, right? It doesn't, but not in OE core. Is the kernel, is it just a reference, or is it actually a production kernel, meaning it's optimized? We just recently went through and we turn on a lot of debug when we build the Open Embedded kernels by default. But Ross, are you listening, Ross? Ross Burton told me just recently that there was like 10 or 15% overhead because we had debug preempt on to track the preemption points. And so we split it into now instruction level debug and runtime debug, so it's not turned on. So that's the question, right? So which that goes to which use case are you trying to optimize? Is your build performance important, or are you more worried about your build system producing an optimized kernel on the output? And that's where I added this last night after going to the Rust talk yesterday. And it comes into, is the build performance important? Because once we start getting required, say, Rust drivers in the kernel, all of a sudden the compiler that some of your compiler providers, anyway, the kernel concerns in your build system now really expand out into the tool chains even more on the way in, because we already bootstrap and build GCC. That's fine. But we all know right now in Open Embedded, when we build Rust, everybody goes and has a coffee and comes back and watch a movie. And on one of my builders that I can't get to right now, it decides to and kill your SSH session. So that happens to me on one of my old builders. So yes, so there's more concerns on that front. And so how is your build system going to solve the inputs of some of these as new requirements come in, right? I mean, the answer is probably for us a Rust binary to get the kernel building faster when it becomes required. But that's the assumption right now, right? So one of the concerns that's TBD that we'll all be running into probably sooner rather than later. On the microphone. I think I'm almost done. How are we for time?
You've answered all their questions.
No, I'm just rambling. Okay, so I'll go a few of. Oh no, I have one more slide. I have to say. Thoughts. These are my thoughts. These are not my answers. I've learned don't give anybody an answer. It depends. Let me get back to you. Let me talk to the team.
Yeah. So one of the things we started doing from the ELISA side is in the users, there's the users documentation, and there's various aspects. There's evidence and personas in there. And I'm sort of thinking that we might want to be putting some of those personas in the users documentation of the kernel and start to clarify this there so that we can all start to come up with some sort of a group agreement effectively.
Yeah.
In a way.
Because I think
That
everybody
might be
just
step.
thinks everybody's building and using the kernel just like they are. If you know, what I mean, like it's the developer, I guess, would be the one that everybody assumes everybody else is doing. But as a load build delivering, it's much different. It's completely different, right? You don't care if it takes 12 hours to produce a signed and cryptographically perfect and reproducible everything. But if your boss is looking over your shoulder because the boot's inconsistently going, you don't want, and yeah, so it's a completely different world, right? And you have your own patch. How are you changing the source? Where you rebuild? Yeah, like, yeah, is it part of the build system or is it not? Completely different. Oh.
So yeah, net is, can we look at trying to put some patches in the upstream users documentation?
Yeah, I'm
Okay,
sure
work on
that,
it
yeah,
there.
there's lots of strange things in those directories. So, yeah, so my thoughts are, offer workflows, don't mandate them. Like I said, you're never going to pull VI in a guy's cross tool chain that he got off of kernel.org 8 years ago and it runs fast. And he's got his def config that he copies in and builds the kernel and SCPs it to the target. You're never going to really convince that developer that they want to use your build system way to build a kernel. So I'm saying offer a workflow. If it actually is good and efficient, then they will adopt it or not. There's no way to mandate in it, right? So that's why I say that's exactly. Those that want to adopt it will. And almost any, like even 2 seconds of overhead is too much. They're used to typing make and the compiler starts. They don't want to watch bitbake parse for 12 seconds before it starts. So I say your build system should provide flexibility, but you do need to focus somehow your testing on some sort of reference. Otherwise, you're all over the place. And, is it, embedded? Are you optimized for embedded? Is it enterprise? Is it hobbyist? Is it whatever, right? You need something that you can test on. And do not prematurely optimize a use case. Wait till somebody actually has a real problem and you can help them solve it. And again, with the reference, if you need to gather momentum and sort of resist fragmentation in some of these parts, then you do need to offer a reference, whether you're expecting it to go into production and be deployed commercially, you still need somehow to develop. And of course, so there you go. I even had it in there, document. Support model, lifespan updates, etc. Right, personas. So you need to have some way that it's written down. Otherwise, nobody knows what to expect from the build system and the kernel. So for open embedded, for example, out of that list of thoughts when I was going through this presentation, this is what I sort of wrote down for what we could do next. Enhanced testing that goes to, should we be doing more of the runtime stuff and getting a better report so we can hand off to the next person in the chain to say that we at least know what works. And I would say, because if you've been following, we found some fairly unique issues in our last 2 or 3 kernel upgrades from FPU initialization bugs, serial port hangs that were in it, and nobody, literally, if you go look on Lore, where nobody else anywhere was seeing these problems, or maybe a couple of Gen 2 guys eventually found. Anyway, so we found some very strange, some very unique issues from the way that we build and boot and deploy the kernel. So, can we enhance what we do even more to pick those up sooner so we're not scrambling and delaying our release while we're trying to figure out why they're getting intermittent x86 hangs because of the serial port not not talking to serial port 2 was the problem that we had. So there was a race condition. Maybe we'll do more stress testing. Maybe we'll actually run some benchmarks so we can chart over time, what we're doing both on the build side and the runtime side. We want to add some more architectures because right now, for example, RISC-V is not fully one of the supported architectures in Open Embedded in the Yocto project. So if you know anybody who would like to support that effort Richard would be happy to hear from them. Yep.
Hi, Bruce. Regarding the kernel testing, would you think it would be useful if we have like an extra set of configs when we do the validation? Not because the reference kernel comes with a reference def config or created or whatever, right? So what if we increase the coverage of that? I know it would be painful to create use the kernel meta to add a bunch of configs to all the kernels when we're testing them.
Some of them, yeah, we have some of those configs already available. You matter doing. The only thing we want to do is make sure that they're not changing it to the point where we're not testing what everybody else will be running later, right? Like, do we want to test one set of configs and then release it with another,
right?
And have a delta between the two. But yeah, and we're looking to expand also to do, as there's some efforts around a binary package feed and more binary outputs from the project. So as part of that, we could do binary reference kernels, meaning they would be usable on generic ARM64 or x86, and you could just take it and have a quicker start along with the binary package feed. So that's another thing that's sort of what's next, rather than always having to build it from source and interact with the build system at all. Just be a consumer of the output of the build system. And of course, one thing that I'm always trying to do is streamline those developer workflows. So I'm done. Am I at time?
Yeah.
Fantastic.
All right, what? Thanks for coming. Hopefully you all come back after the break. And if you have any comments or feedback for BN or I, we'd love to hear it.
We'd like to do this again on a regular basis.
Thank you, Bruce.
Perfect. Nailing, absolutely nailing.
I'm glad I didn't pause on that weird diagram.
Well, that was more. You have fun just related that with the rules. I know, but all the time. No, I mean, yeah, but we're still thought about. I'm not sure if it's as big as it needs to be eventually, but exactly. Assuming you can do this.
No, you know darn well I know better than that. All the corner cases. All you have to do is think about what corner cases.
Yes, yes.
I'm increasingly getting to a point where I'm sure you
Check, check, 1, 2.
Don't use it as the way you should.
Oh, right. I told him that, so I think so. To use in your shape.
It was up to
well, you know, that's good enough. Yeah, I haven't eaten yet today. Oh, sorry. So we started to talk, and then until the lady came into the forum, and then we did the possible thing. So we ended the possible and we went out the hallway, and then we started over. I always say my most favorite are the Dr. Hooligans because we didn't get kicked out.
I almost said I could this is I do like traffic. I very nice. Right now. Yeah, like yeah. 16. 15 we bought the house, 16 we got married, 17 we go use that. Well, I was going to say we got something.
Because like house earlier married 13, first child 14. And that's why it's snapping. Going to the 3 6.
No, it's. My boss. January. January's yes.
Yeah. Okay, so how about your your problems?
Yeah. Shopping in Taiwan. I was going to go shopping in
No, like, well, oh, yeah. And then budget, and then, and then really now it's like, you know, like that's one. Like managers that census just
I was going to say that there's like I've never used.
It's my first time in the US.
And you're finished. We finally got one. Yeah, don't do this.
You also have some licensing issues, right?
Oh yeah, we.
Something freedom.
Yeah, there you go.
I would say no.
There's not like a high market thing. I mean, It's like you were not, it's like you were looking at this problem, somebody just told you, it's always like, hey, you need to change this. You do not need to change your own. Somebody realistically thinks they're coming in and changing. Otherwise, they're just gonna be. They want to get rid of IT has their kernel tree, and it's a kernel tree shouldn't be until let's see how you're not allowed to say. Yeah, what you got in there? What kind of weird? You got customers. And it's the guys that's like, wait, come in and say, depends on it, go look at it, and give me a specific system.
No. I went down for everything again this morning, and blah blah, person being out, blah blah, priority, blah blah, blah blah, priority, blah blah. But actually, it's true. I was like for a mail drive, which said we found it in the direct results. What? I think. And I was like, okay. Gotta wash hands. Don't report me for inappropriate behavior.
Literally, I was telling you, I always tell people, I'm telling people, listen, that's not over, that guy, literally clutching some cross in front of him. Kernel that word 8 years ago. It's EGCS. It was the best GCS. We actually have a version of a lot of so the only work specific work, a version of long binary establishing it, and we told them, and they haven't fixed it. Oh, we told them. The guy said, oh, the newest version of unfortunately breaks your stuff. And so they hard-coded in PFL. That's because we said like in the next version we're told and it's whatever. I guess that same old firmware developer, he's also going to bash it. It's that just doesn't and then takes me. Or he gets once it was, and they triplet and they just make them good. And then the SCPs think that at a certain stage, you part of the profile. It's a bash script. It's literally what's that? Well, I remember in 2003 that I had to try to figure out how to so I'm more than happy to let go systems and is this animation that you actually so you can make with Yonko, right? Just whatever incantation it appears from somewhere. Was Alex is famous for like 20 hours of Saturday. Take your plate, this plate's got the 3 binary like in it, and then everybody's got it in their email. I have built my. And they copy, and then you're like, so what? Who got? He's got the binary file. Put it here.
Best statement I heard yesterday was not disclosing the person asked a contract, are you Yahoo? No, never heard of it. What are you running?
Sure. He's supposed to change all that. I think you'll see changes. In 2024. Many years after, they're still like, this is 2024. That's why it lasted for so long. Finally, they all disappeared. It was John Williams. Yeah, they had a sold that. The conversation I had with him, he's like, he can see what he's trying to get out.
We have a developer to the rescue for you. We have a developer to the rescue. Are you the developer rescue? Given a sufficiently high level of abstraction, every system is an university.
But he's open.
It does not say open.
Well, something else that they basically doing all the right, it was stuff. I think they're trying to stuff. They just kind of yeah, but it was its own thing. I mean, and then eventually, like I said, they also should be your and then it persisted, and then they got it done. Yeah, I mean, they.
Oh, really? I was gonna say, phosphate. So,
yeah, they're.
I'm not aware of any in that area. But as far as like, oh, yes. Also, I can also get it confirmed that some stuff that's very, very publicly aware in Ukraine.
So yeah, we're speaking about make it faster. And they're like, well, we know the devices are going to change, so we can just pass them from the old kernel to the new kernel. I have some. In most cases, I think Linux is really big.
They're like,
Almost never.
name that system, but I don't know that.
Or something else that's just because it's not in the right state that it's
actually the.
Oh, sure, dude. I don't even have the source. Thank you for your service. Yeah, that was all it is. Thank you for not getting the memo back in, Josh. Well, yeah, sort of. Yes, I
Also, it was the guy one. Because you know, for key things. Also express.
And yeah, he swore up and down that police never places. Lips are never used. It's always been the expert. At the time, I'd actually been talking to somebody at a different, and they were already doing this. They were already running.
Yes, it all depends on your definition of catastrophic environment. But I mean, there's several different versions. Yeah, I mean,
Let me see if I know how to do it. I mean, Beam was doing it before. I assume it's just you click on the plus sign.
It's one of those things, you know, like nobody wants to work.
That one. Well, they're both the same.
Check.
How do I can tell the difference?
The seventh slide is a spelling error. I think it's the seventh slide.
Thank you. Appreciate it.
Yeah, that's the wrong one.
No. Oh, no, that's top, sorry.
Yeah, that's the right one. See, it says upstream instead of upstream.
All right, we're just going to get started. So everybody can find a seat. Can somebody close the door there?
Is it the arrow, or is it space arrow, or the space bar, or is it both?
I think it doesn't matter. I think I used the space of the arrows before.
Okay.
I think it's the arrows.
Okay.
It may be context sensitive, but
that's it.
You're a smart person.
In any case, we are going to get started. And up next, we're going to have John Mason talking about how bigger problems of upstream patches. And again, if anybody has questions or things they want to talk about, just raise your hand, get our attention, and please talk into the mic for the stream and the recording.
Yes, I am a terrible speaker, so asking questions will make everyone happier. So please ask lots of questions. I'm not exaggerating. Okay, so how big of a problem are upstream patches? So what is an upstream project? Yes, some of these are going to be very beginner. I apologize for that, but I want to be as inclusive as possible. So, and also kind of define what terms mean, because some of these variables are overloaded. So in this context, you have the project source code that is then configured and built and packaged and included into a distro, which is then a collection of packages. And if being confusing, please let me know. So what is a patch? So from the previous one, it is a modification of that original source code. That's all. You can do it for a number of reasons, like fixing CVEs, which everyone seems to care about nowadays. There are other bugs that aren't CVEs that you do want to fix. Some people like adding features and enabling cool things.
Like drivers.
Yes, like a driver. Or you might want to integrate your source code into a build environment like a Yocto, like a build root, like even Fedora. Or Debian. Again, these are not all inclusive. These are hand wavy things. And there are other reasons why you may choose to do it. So here's the question. What should we do with this patch that we've just created? You upstream it, obviously. And hopefully everyone that's in this room understands upstreaming, but it's kind of a circular ring here. You find an issue, you fix the issue, you submit it upstream. It's then iterated with the upstream maintainer until they accept it. And that does happen eventually, probably. It's then accepted and released into the new version of whatever software that is. And then you find another bug and iterate ad infinitum. So here's the simple question. Why don't we just use upstream? So some of us have things we work on which are time iterative. For example, Yocto releases every 6 months. You might not be able to release or not able to use the latest version because you're releasing at a certain time point and that one releases at a future point.
I was going to say there's another option too, and it's something that is very common at a lot of embedded places, depending on the industry they're in, or indeed whether they're a part of governments and that sort of thing. And they will say we cannot upstream. And so we're special. We can't upstream. Whether or not you agree with them is a separate piece.
Everyone has an excuse.
Right.
Or upstream won't take it, which it does happen. For example, your unique build environment, they don't care about and don't want to muddy their pristine upstream things with this ugly build stuff. Your feature or fix isn't fully baked. For example, if you're releasing something, you might have to put an ugly hack out there just to get it to not work. So, for example, I think many of us have worked enough to see someone introduce a sleep into something because the sleep makes it work. Yes, it makes your deity cry when you do that. Or there are some examples of essentially upstreams being abandoned for whatever reason. The maintainer isn't there, isn't responsive in a timely fashion, which in some cases might be years. I think we've all seen the internet, the XKCD, where it's the internet and it's just one little tiny pillar of one person maintaining one library or whatever. I guess I should have included that because I'm seeing some faces that haven't seen that. So if you come to me afterwards and I will show you this XKCD, that with the compiling one or the two that will change your life. So we have to keep patches in our distro tree. That's kind of where we're at. Sure, but we can just take the upstream versions and pull those back, and then eventually we'll update, and we're in a perfect world where this happens, right? So there's this thing called drive-by patches. I like the term drive-through because I think it's more accurate because it is fast and it is really bad for you. Drive-through, for people that don't know, is a fast food restaurant where you can drive up in your car, not get out. They put food that's really bad for you in it, and then you drive off and consume it. And it's usually greasy and salty, which are two things that are really bad for your health. So these are patches that are created for the distro, but not submitted for upstream. There are reasons why you want to do it. They're never good. But these are the problems. Whose problem is it? Like this is a real question. Is it a problem for the person that created the patch to fix, submit upstream? Is the impetus on them? Is it on the person that owns the
That's one I'm actually very opinionated on. And I think as a maintainer, if you're taking that patch, and not asking why wasn't this submitted upstream and going through those questions, that's my responsibility as a maintainer. And if they can say it was submitted upstream and I'm doing this, well, then maybe I'll take it. But if they're saying it wasn't submitted upstream and they're not willing to submit it upstream, then my responsibility is to say no, because this isn't the way this is working.
But what if you need it? Like what if your package, and we're all perfect maintainers, but what if your package is really, really, really broken and you can't ship without it?
Ask them to submit. But they have to make an effort.
Yeah.
So if you look at the Android kernel Git tree, there's stuff which is upstream that they pull back, and then there's stuff which is like, oh, it's on the mailing list, and you can go see the thread. But everything has to be. I mean, like a lot of most of the patches have an explanation of why it's not upstream, and I feel like that's a good policy.
Yeah, I'll get it to in a second, but there needs to be a base level of that for best practices, if you will. But we live in the real world and people are lazy. Sorry. But yeah, continuing the point, if the upstream project gets never notified of the problem, will they ever know? It's entirely possible that they won't, especially in an embedded environment where it fixes your problem and it goes out on a drone or something, and like, who cares? Well, people care, and someone's gonna hit the problem probably in the future. And then there's the problem of not only using upstream. So if you fixed it and didn't submit it, it will bit rot. Bit rot is where your patch ages over time, because you update it and things change around it, and it might not apply cleanly, and then one day the sky falls. And also duplication of effort. I think we all know in this industry we don't have enough hands to fix everything, and duplication of effort. Two people fixing the exact same problem is a collective waste of our time. If you disagree, please, I'm happy to argue with you on those. So all this is theoretical, right? Well, I mean, I think everyone in this room knows it's not actually theoretical. So why did I why did I do this talk? So I'm not saying this is the company I work for or a previous company, and I'm not going to name the product, but a board support package that I may or may not have maintained had a U-boot patch which was enabling this platform, allegedly. And so the person that enabled it put it in there and put it as a pending state, which I'll get into states in a second. And for 4 years, I asked this person, you're going to upstream it, right? You're going to upstream it, right? You're going to upstream it, right? Of course. And then we may or may not have released a new version of a layer I may or may not maintain. And I asked again, so you're going to upstream it, right? And this person had to move on to a new project. So I asked the person that's doing it now, and they're like, no, we're just going to drop support of the BSP. That's like a little soul crushing, right? Like, instead of upstreaming a very trivial patch to enable a board, they're just going to allegedly. I'm not saying this happened. This could be fictitious. So yeah, so that hurt a little bit. So we have patches live in our trees forever. This can't be true. This can't be the answer, right? So Yocto. So I'm doing Yocto first because it's what I work on, or open embedded, and it's easiest to generate the data from, and you'll see why in a second, because Yocto actually has different types of patches. So I did some terrible shell scripting, and I went through and I looked at the type of patches we have for the latest version that came out last week, right? NetBuild came out last week. Yeah. So this is fairly cutting edge. So 200 of them are backports.
You didn't mention the upstream status mandatory field for the patches. How do you get that information?
Sorry. You mean this slide?
The next one?
Yeah,
Okay.
yeah. So I'll go what all these mean in a second. It's kind of a
Out of
chicken
order.
and egg problem. How can I describe what they are, and then tell you what they aren't? Like, I guess I could have gone another way around. But anyway, so yes, 200 are backports, 253 are pending, 452 are inappropriate, 232 have been submitted, 19 are denied, 21 are inactive, and then we also have a separate field for CVEs, and we have 69 of those. I'll leave that one alone. So what does that mean? So what is pending? And if you wanted to click on the link, you can actually, there's a big article in the documentation, what these mean, and a better description than I'm giving. Pending means you're going to do something. Pending is the problem.
I promise.
Yes, I pinky swear that something will happen. Submitted means you've submitted it upstream, usually a like lower link or something like that, depending on what the project uses. Backports are fantastic. You essentially usually have a SHA where you've backported it from, and then when you rebase, like it'll magically melt away, and those are fantastic. Denied, you've made an effort. It's similar to submitted, but you know the outcome. But at least you've tried, and now the world knows there is a problem. Inactive upstream, self-explanatory. Inappropriate usually is for your build system. For example, you need to fix the path to something, or pull in a certain kind of thing that lives in another place. They're pretty unique. There are numerous, but they're numerous because you need them. Questions about that? Do those make sense?
You still didn't specify what upstream status is, how it's, well, what types are there, but
Yes,
saying
so-
it's a tag that is mandatory
Yes.
for all the patches.
Yes. So, and I'll get into that in a second, but yes, in every single patch in Yocto, with a few exceptions, legacy exceptions, there is a field in every patch as part of your commit message. What is the upstream status? Right?
Hey, John.
Yes, sir.
That's for open embedded core. It's, the policy is on a per layer basis to be.
Yes.
It's becoming the compatibility. Not the project.
Okay, I happen to have a layer that I don't put upstream status on, but that's because I know that not every layer is going to do this, and I'm guilty.
Yes, and without getting into the weeds of what Yocto and open embedded are and
Yeah.
how they overlap and know that kind of stuff, it is highly recommended that you do this. Everything for does this and has done it for some time. Question over here.
So just really quickly, I was going to have a question myself. Yes, this is an open embedded. This doesn't sound like it is. Somebody else could use this in a different build system.
Yes.
So the same metadata could be used by a build root, for instance, or whatever else,
Yes,
which is really cool.
And Buildroot does have, without
I'm
running
sorry.
ahead.
Apologies.
No. Like, people are going to have these questions.
Doesn't Debian do something similar with its patches?
I'll get into why other distros and why I don't have good data.
How strict is the project's policy around denied? Because to me that seems like the most red flag around, like, that's upstream has rejected it.
Yes, like if you look at the numbers, they're very small numbers.
Yeah, because that seems like obvious technical debt of like rebasing on those is probably going to be the most painful.
But in theory, something, because there is now a known problem on the mailing list, there will be a fix, which in the next release should throw this away and roll back on. In theory, hand wavy kind of stuff. But yes, it is a red flag.
I would tend to say it can be very complicated.
I work at Red Hat and for RHEL. We have similar tags like this for upstream status for our internal patch. We have maybe a couple hundred internal only patches for RHEL. That same reason upstream didn't want. A lot of it's around features or security hardening that upstream isn't interested yet, but we need to for compliance reasons. So, we have we use get jerry pick. So that by having a hash in there, it automatically describes the backport. Right, you don't need backport, but we do have you do, if it's only rel only, or if you submit it to something that's like a pending, we give a link to a tree of where it
Yeah.
is and what tree, it could take a couple months to kind of propagate up to Linus's tree, but no, it's popular for us. I think it's a good idea.
You say the inappropriate status is for things like build system patches that aren't appropriate upstream, but do you ever try submitting those upstream anyway? Because maybe upstream wants them regardless.
So actually, some of those denied tags, it's technical debt, yes, sure, but sometimes upstream project can come back and say, we do not support cross-compiling. We only support native compilation. So, and that's the patch that we need to carry ourselves to enable cross-compilation. And build system-specific patches, yes. So we try to submit them upstream, and sometimes they are being denied.
I'm more concerned about the pending. I think what you're describing is submitted, but pending. Pending means you're going to submit it.
Yes, but like.
Yeah, you don't allow pending.
Yeah, but pending is the problem, and running ahead by identifying these states, you've kind of encouraged people by making it mandatory to have these things in there. You've kind of encouraged someone to do what you want them to do anyway, right? By defining the problem, you're slowly solving the problem, running ahead. Yeah. So
isn't inactive upstream also pretty awful? Like if upstream's dead,
well,
why we should drop it, right? Like
there are, without I know of projects that are 20 years old that are still in use because they're so ubiquitous that, but you could argue, then why do those need to be patched? The world changes under you, and if no one's going to respond, anyway. I mean, would you want to maintain a project that's not yours, that's 20 years old, and pull in patches? I wouldn't.
Speaking to that, I mean, are you aware that ISC DHCP is dead? How many? Yeah, I was gonna say, how many people in this room are still running ISC DHCP? I mean, very few people have switched off to Kira, whatever the Kia. Thank you. So yeah. Just because it's dead doesn't mean that it's not still useful. So there's so many projects out there that upstream no longer exists for, that fundamentally you can't get rid of. Like there's just no. I was going to say, how many people in this room or even have vaguely thought about moving to Kia? Yeah, like there's good luck.
We could probably just put it in System D, right? Okay. Are there more questions?
Yeah.
Keep going.
Go ahead and slug through another couple slides.
Okay. So Pocky 4.3, just to mess with you, Yocto does have names and version numbers, and they're used interchangeably. So I'm going to use them interchangeably, but the numbers don't matter because decreasing means older. So 4.3. So we have roughly 450 just like the slide I was showing you before. You can kind of see visually the numbers. Those are always nice to see. And here are the ages. So these you can the day numbers are kind of ugly. These are 6-month chunks, and this is for pending, I believe. No, that can't be right. Anyway, so you can see, since Yocto has 6-month iterations, of course, things that are 6 months or younger are going to be more frequent. But you do kind of want to see this kind of long tail. Theoretically, there should be zeros closer to the end here. But things are melting away. But what's old? So these are pending. And we have 13-year-old patches, and I'm willing to bet money that they're 13 years old because we moved to Git 13 years ago.
Wild time.
So Tickle TK, Xorg may or may not be dead, so maybe it just gets dropped at some point. I'm not going to make any argument like that. No one uses IP tables, right? Drop bear. Yeah, so it is kind of egregious that these are old and pending. But it used to be worse, right? So this is 4.2. You can, I guess if I had animated it, you could see it like shrinking, or actually technically growing over time, because we're going back in time, much like Back to the Future. So yeah, I'm just gonna click through these. You can see the numbers are slightly higher. Same problems. 6 months ago, it was still 13 years. 4.1, numbers are slightly higher. You can look at the slides. I don't think it's super interesting to anyone else to for me to point out the exact numbers. Slightly higher, but still the long tail. Okay, so this was 2 years ago. I think that number is slightly screwed up. Number slightly higher. Again, I don't think these are super interesting, but someone did the graphs for me, and I don't want to waste their time by not showing them.
There's progress then.
Yes. So what I'm attempting to show over this is, because Yocto's been doing it this way and open embedded for a number of years, the number of pending patches has decreased over time.
That's with new ones being added.
Yeah, the new ones are being added and old ones are rolling away.
It's still going down.
Yes, and it's still going down, but it's like around 2,000, and now we're around 1,700 collectively.
But pending going down doesn't necessarily mean they have been pushed upstream. They could have been marked like...
They could have been thrown away, which I would argue is still a win, because there's no technical debt, right?
Okay.
Or maybe that feature was never actually used, so they threw it away. I mean, there could be a number of reasons why you remove patches.
We're getting a little bit stricter by asking people to have at least submitted, not pending patch. So
there's a comment as well last year. Talks about applied upstream.
Yeah, and that might be part of the problem of why I have garbage numbers for distros, is because I'm not using the keywords, the correct keywords. So blah, blah, blah. Does look like it was actually out of order. I apologize for that. Okay, so build route. So I looked at the last release. There are roughly 1,600 patches, 35 with upstream status set. Again, this isn't they don't use this policy, so of course they don't have these restrictions. And I'm willing to bet that the 35 are from Yocto, that they pulled over for fixing a similar problem.
You mean the ones we copied from Debian?
Sorry, from Gen 2.
From Gen 2.
There's a lot of patch sharing.
Only 2 were marked as a CVE. I think that probably is something, without knowing the intricacies of build route, they probably want to use some kind of demarcation of CVEs, because that is something that I think people are going forward going to look at more frequently. Yeah. And the upstream status, because almost none of them were demarked, I marked all of them as null. It's a crap data point, but it is a data point. And so here's a different way I tried to look at it. Because it's all in Git, I tried to see how many have been modified frequently. To me, that is something that's been carried around a long time. It's been modified frequently. It's really hard to read, and it's even harder to read over here. But things that have been modified once, which is the original commit, is somewhere around 1,700, 1,300.
1,300.
And then modified 2, but there are 2 that you can see here in the long tail that have been modified 14 times, which means they've been around for a long time and they've been modified frequently. That's probably something that's either related to how they build or it's something they should have pushed upstream. I wasn't able to get in the weeds to figure out why they didn't do it, and I didn't think it was really that interesting, but I could be wrong. And then I tried to look at Fedora, and this is going to be pretty terrible. So before you look at the number, let me explain why it's garbage. So with Buildroot and Pocky, I'm able to get a Git tree that I can parse and use Git history to look at real numbers. I can't do that with Fedora because there's no canonical tree that has all the sources with all the patches that I can parse. So what I did is I downloaded all the source RPMs and ripped them apart. And then I looked at all of them and looked at them like patches. And if they're patches that are with, Git format patch, then it'll have a properly formatted email header I can parse. A lot of the vast majority of them don't. So I can't generate any, and I mean, there's 17,000 patches, obviously. Pardon?
Well, no, this is for the full distro of this. We have the source Git tree for the kernel, but most of it's still maintained in this Git. All of that is actually still on Fedora, and you can look at the patches there. There's Git trees for each of the disk Gits.
But would I need to go in each individual one and clone each individual Git tree?
Yeah.
I mean, I guess that's not that much worse than ripping apart every source.
It's scriptable. I'm not saying it's
Yes.
No.
And that might be worth doing. Essentially, this is one of the ones where I hit this roadblock and ran out of time, and I'm like, okay, future work. But yeah, so of Fedora 36 that I ripped apart, there are 13 that are marked as CVEs and 2 have upstream statuses. Again, there's no uniform way of doing this. To Masahiro's point, there are probably different keywords that I'm not looking for that I probably could have been smarter about.
Well, I mean, so Fedora is an interesting one because.
Sorry. So Fedora is an interesting one because RHEL has requirements for upstream first. I mean, that's kind of our policy there, right? And so we do also have requirements for upstream status being patches, those types of bits. Fedora, all the RHEL packages are in Fedora, and so those are usually maintained in a similar way. A couple of them are maintained by community instead, but we've also got a lot of packages that are not maintained in that way. They're maintained by someone else. So it gets, there's not a lot of uniformity around there. There's not a lot of policy around there. And because these are not employees, these are community, you can't really force, I mean, we can force some, but you can't force too much.
Yeah.
This is actually interesting. And you're right, you can't force it, but it can be gamified. And so to a large degree, I think comparing these different build systems in different communities is actually really interesting because it means you can start, not quite shaming, but you can at least give them numbers that they can work towards, improvements or whatever else, or sharing. Because I mean, clearly there's got to be commonalities between some of the patches that have gone between different things. So this is actually kind of an interesting idea and an interesting thing to have done.
So I also tried to do something very stupid as well, and essentially ran diff. I did a find of every single patch, and then ran diff to see if I could get a match, and that was running for days and days and days with no hits. So, and there's probably not enough of a fuzz to make it actually worthwhile.
We should probably move to Alejandro.
Okay, so like 2 slides to wrap up. Okay, so are there things that we can do commonly to make this better for everyone? And if we could all use Git format patch or something like that, so we actually have email headers so that something like this could be scripted, so you could tell the ages and that kind of stuff, that would be something. Adding an upstream status or similar field to know what state all the patches are in would be something. And I think it would be something we could be measurable. And to the point, if we only allowed patches that have been submitted or even accepted, then there wouldn't be a problem. But also, the streets would be paved with gold and everyone has a fuzzy kitten or something.
Everyone would use upstream kernels.
Yeah.
Well, I mean, I haven't really had much.
Sorry, I haven't really had much problem with saying if it's not submitted, I'm not going to take it. And usually I say I want submitted. I would want at least one review upstream to get an idea where it's headed.
Mhm.
But I mean, I haven't run into anything critical that I can't take.
Well, but you also, are you supporting any hardware where you have to get the release out so the hardware?
No, well, I mean, yes, we do, but no, we don't.
Yeah.
We support.
Yes.
And there's still the problem yet that your upstream just might be dead. I just took over a project which I actually believe the maintainer died. And so, yeah, he was an active contributor to open source, and from one day to the other he
just
disappeared. So, and that was like not 30 years ago, but like 5 years ago. So I just took over the project, went through all the distros, see what patches were flying around. Of course, there were duplicated effort, and try to get a new upstream so that we have a new point. But there, as you know, there are lots of projects where nobody stepped up to continue the work.
By the way, accepted is incorrect field. So if it's accepted, it's actually becomes a backport.
Yes, if it has been accepted, it should be a backport. And you could even make the argument that the patches should get redone once they get submitted, so that the backport goes away when you rebase.
Git notes. Just use a Git note.
I'm not familiar with that one. Git note?
It lets you attach metadata to a commit that already exists without having to like
Okay.
redo the commit.
Cool.
Yeah, that's cool.
How do you view the notes?
Git, yeah.
Okay, anyway, I think I'm out of time, right?
Yeah, we
Okay,
should.
cool. Thanks, everybody.
It's been looking at raw computers for how like there's stuff in the arm, have a attack or that's not getting hurt. We're very sloppy about that. Very long time the arm flex that they goes to this policy.
I mean, there's, yeah, I feel like actually on our side, our PC injected it from these voluntary because
Yeah. Okay, Alejandro is going to talk to us about building for heterogeneous systems, which is a word I can't pronounce very well.
That's great. How's it going, everyone? So my name is Alejandro Hernandez. I'm trying to put a sticker, but it's not going to work. So I'm going to talk about building for heterogeneous systems. What else? I work at Microsoft. Views are my own. So again, we're going to talk a little bit about heterogeneous devices. So I'm going to use the term interchangeably. Like sometimes I say system, sometimes I say architecture, sometimes I say devices. I refer to the same thing. We're going to see a little bit about how the Linux flow works and how the bare metal flow works, or what's the expected way for it to work. I know this is the Linux plumbers, but we're going to talk about bare metal and RTOS builds as well. Working with SDKs, with the Raspberry Pi Pico and Zephyr as examples. And specifically, I'm going to talk about the current BitBig solution that we have, which is multi-config, and how we can test this heterogeneous builds. So, a heterogeneous device, sorry. Essentially means that there's multiple architectures on the same device, on the same system. Typically, there's a big core and there's a small core, and then the big core is going to run Linux. The small core is going to run an RTOS or bare metal application. You can do anything, right? But this is typically the way it works. The reasons for this vary, but usually they're related to like power consumption and safety critical applications on the RTOS, processing power. In general, it just makes your device more efficient if certain tasks are done on a certain core and not the other. Again, like I said, you can do any combination at this point, right? Like you can just run Linux. You can run Linux and bare metal, Linux and an RTOS, only bare metal, only RTOS, or Linux and Linux. And that Linux can be different than the other Linux, right? Like it could be an RT based, or it could be a tiny or whatever. It's up to you. It depends on the answer is always it depends, right? It depends on the application. Something is going to work for you and it may not work for some other person, developer. essentially, the way this works at a high level is you create a cross toolchain for architecture X, you create a cross toolchain for architecture Y. Package A is compiled, cross-compiled for architecture X, package B is compiled for architecture Y, and at the very end, you sort of like package it in a way that it's deliverable, the artifacts for either of the systems, either the images or binaries in the other case. So in my opinion, the main issue with this is that the flows for developers are different, and that's why it's a complicated problem. For Linux, we have mostly figured it out. Usually you have like a Git repository, you get the sources from somewhere. You grab the toolchain from the host. Obviously, if you have like an actual build system, like Bitbig or whatever, you're gonna get your toolchain from there. But if you go to like any repo for like an open source component package, it's literally the instructions are gonna say download the package, the toolchain from your package manager, and that's supposed to work, right? And you can do whatever IDE of your choice. For bare metal, that's usually not the case. Sure, the sources come from somewhere, but usually you get like a vendor-provided toolchain, and a vendor-provided SDK may be there, a vendor-provided IDE that's wired with that toolchain, and it needs like specific, you like to do the dance around what it's compiling or something to make it work. So it's complicated. For Linux, in the current Bitbig solution is Deptol, and I think it works fine, but it's not as simple for bare metal applications. So the bare metal toolchain. If you were to build a bare metal application, I'm using the ARM embedded toolchain as an example. It's usually going to tell you, hey, go to the ARM's website and download the ARM embedded toolchain. It provides GCC, it provides VinUtils, and it provides NewLib. But that's fine, it works. You could also integrate it in your current build if you're already using Bitbig by setting your tclibc variable to NewLib. You'll essentially you'll emulate whatever you're getting from the ARM embedded toolchain, just newer versions. Right. So how does in my defense, we didn't know it was going to be this small. So I know you guys can't see anything, but I'm going to try and explain it real quick. This is bare metal first. So in OE core, there's a package that's a reference for bare metal. This is the repo for that package, and it has like the instructions. There's nothing great. Oh, there we go. Oh, it doesn't work. Okay, $5. Useless. Yeah, okay, I'm just gonna use the mouse. You can barely see it. Anyway, so first you clone the repo, of course, you source the environment, and in this case, I'm using a QEMU ARM64 machine, and I'm simply setting the tclibc as bare metal. So as I told you, you could set it to NewLib as well, but if it's bare metal, it could be bare metal, and there's essentially the same thing without NewLib. And then you just bitbake bare metal hello world, and you'll get a bare metal application as a reference again. It's wired up with QEMU as well, so you can just run QEMU on it, and you'll get a hello message there that says hello open embedded. This works for QEMU ARM64, x86, x86-64, ARM v5, RISC-32, and RISC-64. So you can, it's the same thing. It's just the message is going to change. The source code is not actually the same because there's like linker scripts and stuff that needs to change. But either way, you should, as a developer, you should now not see anything different. So what if you wanted to build something a little larger, like an RTOS? In this case, I'm using the FreeRTOS example with the Meta FreeRTOS layer. The instructions are essentially the same. The only extra thing there is that you add a layer, the Meta FreeRTOS layer, and you set the distro to FreeRTOS, you set the machine. In this case, I'm using QEMU ARM v5, or you could use, there's an STM32 microcontroller you can use, those Nucleo boards. That works as well, or the Raspberry Pi Pico as well. Again, pretty simple. Bitbake FreeRTOS demo, and then you can run QEMU, and you should see the output on your serial console for QEMU at least. Obviously, if you connect the board to the serial console, it should work as well. So this is how. Right. So this is tackling the problem, the simplest problem first. So how do we build it separately, right? There are some cases where like I said on the developer workflows, sometimes you get a vendor provided SDK that you kind of need. So you need to wire that up to be able to work with their current flow. For example, the Raspberry Pi Pico and Zephyr, they have an SDK. There's several approaches you can follow here. I'm not saying one is better than the other. I am saying one is better than the other, but there's several ones. The approach one is you create a native recipe that provides the SDK. What it'll do is you'll fetch the SDK from whatever you're supposed to fetch it, and then you install it, and then depend it on the application recipe, right? So it's by the time you're building your application on the recipe-specific sysroot, your SDK binaries are going to be available, right? That's the best approach, by the way, and it's a fact. I'm just kidding. The approach number two that you can also use is on the application recipe itself. You can fetch the source code for the application, but you can also fetch the SDK there and then wire it in and use it from there. It depends, but I think the other one might be better or cleaner, if that makes sense. Right. So now we know how we can build them separately, right? So how do we build the whole thing for the whole product in one build? This is where Bitbake multi-config comes into play. What does that mean? It means that you're manually configuring Bitbake to parse an additional conf. Usually, you get your, like, by default, you get your like local.conf, and that's your main configuration. You can put variables in there and whatever. And in this case, you're telling Bitbake, hey, parse this other one that I want to build as well. There's this concept as well of multi-config dependencies that allow Bitbake to use the same build and to use two builds, if that makes sense. It could be different. You could use different tool chains. You could use different OSs. It doesn't matter. You can just do that. The one really good thing about that is the shared state can be reused across multi-config, so you don't have to like rebuild everything. At least the native part of it will be reused, right? Because if you're building for a bare metal stuff and then Linux here, obviously you can't use that, but native stuff can be shared. So it does accelerate things quite a bit. So how do we make this work? It's actually quite simple. I put an example here. On your local.conf, you set your machine. In this case, my main build is a bare metal one. So I'm setting the STM32 as my machine. But the interesting part there is the last variable, the VB multi-config variable. I think you can see it. So it's great. And in that one, I'm specifying the name of the config that I'm telling Bitbake to parse as well. And then there's a directory called multi-config where I put that file with that same name, dummy arc64. And in that file, I am creating a separate build. In this case, again, my main build is going to be a FreeRTOS with STM32 as a machine. And the other one is going to be a QEMU ARM64. The distro is going to be Pocky. And I'm only switching the temp directory for that one. And lastly, I'm creating a multi-config dependencies on the last line. It's a little convoluted, but essentially what it means is I am telling the ARC64 build for when I'm building core image minimal for the ARC64, I'm telling it that the do image task should depend on my do image task for the FreeRTOS. Hopefully that makes sense. basically, whenever I issue the command to build core image minimal for the ARC64, it'll automatically pull the FreeRTOS build as a dependency, and it'll build both things. I am sorry that you can't see anything there, but is there a question?
Yeah. Does it matter which one is like the main config?
It doesn't matter.
You would have to swap around that.
You just swap it. Yeah, it's the same thing. I just used it, to switch things up a bit, but it could be the other way around. No problem.
Like when you do like bit core image minimal, like the
Oh, I'll get to that in a little bit. I'll make sure to address that. So you can't see anything there. I'm sure the virtual folks can, so which is good. But what I'm trying to say here is that there's two. Usually, when you try and build, you only get one of those, right? You only get your default config, and now you have two. Again, you can't see, but one says that it's building for ARM OEAVI, so that's a bare metal toolchain, and the other one says it's building for Linux. So that means it's working. BitBake is parsing the extra conf. And this is the way it works when you're building. You can see, you can't see, but it says there that it's building the FreeRTOS demo for the main config. And you can see a small MC prefix on the other one that's saying, for the dummy ARC64, I'm building core image minimal, right? So, and that's the way you address it. If you want to build for one or the other, in this case, like the core image minimal is depending on FreeRTOS, but FreeRTOS is not depending on core image minimal. So if I build FreeRTOS, it's only going to build FreeRTOS. If I build the core image minimal, it'll pull the other one, right? And if you want to, again, if you want to build a specific one, you type MC as a prefix. So BitBake MC quotes, and then the name of your multi-config, and then the recipe that you want to build. So in this case, the command I'm using is BitBake MC quotes dummy ARC64 core image minimal, and that's building both at the same time. This is how the artifacts look. Again, you can't see, but that's great. On the first one, I see the artifacts for my Linux build. I have my kernel 6.5, which is great. And I have the binaries, the green ones that are in the bottom, they're the bin, the elf, and the hex file that you're supposed to flash on the other device. Testing. Sorry, did I address your question with the MC prefix? Okay. So testing different OSs can be done with open embedded infrastructure, existing infrastructure, to some extent because it was designed for Linux and it has certain expectations of how that's supposed to look. Like at some point you're gonna see the prompt that says root, right? Because you're the root user, and obviously that's not true for like a bare metal application or something. So if you can emulate that in some way, you can use that and test it. But these are still treated as separate builds, if that makes sense. Hopefully you can see a little bit better there. But as you can see, I am calling the test image task for core image minimal for my big core. So MC big, it means I'm building for the Linux one. And the other one is MC small, and I'm building like the bare metal application and running the test image task for that one. So future closing thoughts, whatever you want to call it, open questions. So building your own cross toolchain, it provides some advantages. Like you can get access to like newer versions really fast. Obviously, you can quickly fix. It's up to you when you fix things, right? Like you don't have to wait until like a CVE fix for stack protection for ARC64 cascades all the way down, right? You can just put it there and you're done. So there are good reasons for you to use your own cross toolchain. Again, I'm gonna kind of reuse what Bruce said before. We're not mandating that you use it. If you want to use it, go ahead. It's possible, and it has its pros and cons. There's a question. Oh, and then specifically for bare metal stuff, the vendor ID may not use exactly the upstream toolchain, and it could be, again, it may ask you to like dance around with what's compiling or something. So it's complicated. The one thought I have about multi-config is that right now you're describing the build, right? You have a build and you're saying, oh, I built this thing as well, but that's the build. That's not the product. So if you have a product that has two different architectures, you're not describing that. You're doing it per build. There's no like system variable that includes two different machines or something like that. So that it works. It just it may be able, we may be able to get it better. Is there a way that we can describe a full product, a full model of something that has two specific models of or architectures?
Yeah, and I wanted to touch on that one. So yeah, right now multi-config you can do multiple images basically, and you would then have to flash them separately.
Right.
And so how do you do a product then? And next step would be, how do you combine all that and maybe have an SDK with
both
of them, yeah, multi-config. And yeah, several people looked into that. I looked into that as well. So for example, MetaTI uses multi-config to build native SDK, to build bare metal pieces. So some former images. So the newer TI parts, they are heterogeneous SoCs, and they do require some of those bare metal components. So yeah, and that piece is not yet fully supported in Yocto, unfortunately, at this point. So we do we can do multi-config builds, get the images, but then how do we then put it, wrap it up into a product? Like
right, exactly.
So that's still open question. So and there are different implementations. I've looked into doing native SDK tool chains and basically wrapping that and having a final product with multiple tool chains, one for Linux, one for bare metal. Yeah, so that's yeah.
Yeah, there's I'm actually kind of guilty about that because I own the bug for multi-config SDKs. So, but it's a complicated issue for sure. I guess things have gotten better. So if I look at it again, maybe it'll just, the answer is just right there. Also, it's kind of complicated to integrate into like the vendor workflows. So we kind of want to make it easy for the user to, I guess, switch. Don't mandate, but I make it easy for them. And it's complicated because vendor X has a way to flash things, and then vendor Y has a different way of flashing. So it's a complicated problem. We may be able to get away with like sort of like a common way that it's modular, and you can switch things up a little bit, and it's gonna work for you. So yeah, the open question I had there was like, how can we integrate better with vendors and their current workflows? And I think that's it. Are there any questions? We still have 5 minutes left.
Tying into my question from earlier, later in the talk you showed like MC little or MC small and MC big.
Right.
Can you refer to like the non-multi-config?
Yes.
With that MC prefix?
Yeah, you don't have to, because if you just type big whatever, it'll automatically do it for the default. But if you want to refer it, it's probably cleaner. You can just do MC quotes and then quotes again, as in like an empty string there, and you're referring that way to the default one. Oh, default's a keyword now? Okay. He just said that default is a keyword.
So also, so BitBake uses this syntax. So the multi-config colon, the name of multi-config, and then the target. Internally for MC depends, you actually have another field. You want to cover that?
Sorry, what?
Internally in the MC depend, where like you had another example if you scroll back. Yeah, there. So you have actually double column there. So can you explain that?
I created that. I don't remember what it is.
Well, actually, in BitBake, when you actually call BitBake, you specify MC colon and the target.
Oh, right. It's the other architecture. It's the other multi-config you're depending from.
And here it's like from and to, yes.
Right, it's from and to. So the core image minimal from the dummy ARC64 will depend on the empty, in this case is the empty string, which is the main conf. That's why it's depending for the image task for the FreeRTOS image that's coming from the main or default config. Yeah. In the documentation of the Octopart, you can find it. There's a good explanation there.
So where does this FreeRTOS demo STM32 come from?
The recipe from so that's the package that you're building. That's the name of the package or the name of the recipe,
okay.
and it's coming from the meta FreeRTOS layer.
And this recipe is designed to be run from the AR64 config.
Which one? Sorry, which recipe?
The example, the core image minimal, that's designed to be like in the AR64 multi-config.
Sure. Yes, you can put a BB append and use it on your own architecture. And it could be any image. I just use the core image minimal as an example.
So the FreeRTOS demo do image task
Right.
is taking the built free image and installing it into lib firmware somewhere?
It is.
Okay, and so it's sort of a partial rootfs image, and then the two rootfs images get pushed together.
So you'll get a rootfs for Linux, not for FreeRTOS, but you'll get an RPM or dev or whatever that you can also use and update. Let's say you wanted, like, from your big core, you can in user space you can flash the other core for whatever reason, right? So you can technically do an update with a package manager, get the latest RPM, dev or whatever on your system. It will install it in lib firmware, the new binary, and you can then flash it using something in user space. You'll find it, yes.
So yeah, and there are challenges there as well. So first of all, there is a separate temp dir for another multi-config, and one of the challenges is basically to get in artifacts across separate temp
dirs. Yes. Because one build is not aware of the other one, really.
Yes. And even more challenging is actually to use to generate the final weak image, because weak image has absolutely no knowledge about separate temp dirs. And you can specify boot files for weak image. You want to actually put in a separate partition, but they have to be in the same deploy area. So that's what I faced. Actually, I had to combine deploy directories from separate term directories, because weak cannot access across separate term.
So the only workaround that I've done in that case is you know the name of your multi-config, right? So you do something you're setting. The build system is not aware of it, but you can declare a variable and with the location of your artifacts on the other config, and you can grab them from there. It's not great, but it works.
No. This is a great conversation. We all have processors that now have many other processors running stuff that isn't Linux, and building it is important. But it is now lunchtime, and we are going into lunch.
Thank you.
So we may all go to lunch now. Please, thank you all for coming. Really, really glad that people showed up.
And you can keep talking outside.
Exactly. You took the words right out of my mouth. Please go outside and continue the conversation at lunch.
Yes. Thanks, everyone. You want to see throw it up there?
There's also a reason why I'm not a wide receiver. And no problem.